provinsi paling barat Indonesia yang bernama Aceh menyimpan catatan sejarah yang panjang dan melegenda. Wilayah yang pada masanya dulu pernah menjadi kesultanan besar yang disegani dunia ini juga tanah yang dikenal dengan kekayaan alamnya. Selain keindahan pesona wisata yang memukau, Aceh juga dikenal sebagai wilayah pertanian dengan hasil yang melimpah ruah. Sejarah mencatat jauh di masa lalu, wilayah ini sudah menjalin kerjasama perdagangan lada dengan dunia internasional. Semangat kejayaan pertanian itu pula yang menjadikan kota Banda Aceh sebagai lokasi berdirinya Fakultas Pertanian Universitas Syiah Kuala. Tempat ini menjadi saksi dari dedikasi, impian dan kerja keras yang membingkai harapan untuk mengembangkan dunia keilmuan pertanian di Aceh dan Indonesia. Fakultas Pertanian merupakan fakultas ke-6 di Universitas Syiah Kuala yang lahir pada tanggal 18 Agustus 1964. Dan saat ini, Fakultas Pertanian telah berkembang demikian jauh sehingga telah memiliki 8 program studi sarjana, yaitu agroteknologi, agribisnis, peternakan, teknik pertanian, teknologi hasil pertanian, dan program studi ilmu tanah, termasuk 2 program studi teranyar, yaitu proteksi tanaman serta kehutanan. Selain itu terdapat juga 2 program diploma, yaitu program D3 Manajemen Agribisnis dan program D3 Budidaya Peternakan, serta 4 program pasca sarjana, yaitu konservasi sumber daya lahan, agroteknologi, agribisnis, dan teknologi industri pertanian yang semuanya pengelolaan dilakukan oleh program pasca sarjana Universitas Syiah Kuala.
Visi Fakultas Pertanian Universitas Syiah Kuala menjadi pusat pendidikan, penelitian, dan pengabdian masyarakat yang unggul dan terkemuka dalam bidang pertanian berbasis sumber daya dan kearifan lokal di Indonesia pada tahun 2020.
Untuk mewujudkan visi tersebut, Fakultas Pertanian Universitas Syiah Kuala mengembangkan sistem perkuliahan yang berbasis pada kompetensi pertanian secara terpadu yang relevan dengan kebutuhan masyarakat Indonesia dan global. Pengembangan ini didukung sepenuhnya oleh seluruh sivitas akademika fakultas ini. Salah satu dukungan tersebut tercermin dari aktifnya para dosen dan mahasiswa dalam mengembangkan riset-riset unggulan pertanian yang berpola keilmuan dan teknologi, berorientasi produk, dan berbasis pengabdian dengan tetap berupaya untuk mengembangkan potensi lokal. Sebagai hasil dari sistem tersebut, beberapa inovasi dan produk dengan pencapaian istimewa bahkan telah berhasil diwujudkan oleh para mahasiswa jauh sebelum mereka menamatkan jenjang pendidikan sarjana mereka.
Pada saat ini kami telah mengembangkan suatu produk primadona bumbu masakan khas Aceh yang dapat memberikan rasa kesegaran, rasa asam segar pada masakan, dan juga dapat menghilangkan bau amis pada masakan ikan. Pada saat ini, produk ini telah kami pastakan sehingga penggunaannya praktis bagi ibu-ibu rumah tangga yang memiliki nilai kesibukan dalam kehidupan sehari-harinya. Produk ini juga memiliki nilai kehigienisan sehingga dapat disimpan dalam jangka waktu yang lama.
Untuk mendukung sistem perkuliahan yang aktif dan berbasis teknologi, Fakultas Pertanian Universitas Syiah Kuala juga menyediakan berbagai fasilitas seperti laboratorium, bengkel teknik, kebun percobaan, serta berbagai sarana lainnya.
Untuk mendukung menjadi pusat penelitian yang terkemuka juga, saat ini Fakultas Pertanian telah mengembangkan beberapa sarana dan prasarana yang memang secara fundamental sangat diperlukan. Saat ini kita telah mengembangkan 1 rumah kaca, 1 rumah kasa, dan kebun-kebun percobaan. Kemudian didukung juga oleh laboratorium-laboratorium dan tenaga-tenaga laboran yang tentunya memiliki kualifikasi yang bisa kita andalkan.
Tidak hanya berhenti sampai di situ, Fakultas Pertanian juga mengadakan case study dan study project dengan pendekatan multidisiplin serta mengembangkan fokus research area untuk memberikan sudut pandang dan pengembangan wawasan sesuai dengan perkembangan dunia.
Kami berkonsentrasi di bidang penelitian dan pengabdian kepada masyarakat untuk mengeksplorasi agen-agen pengendalian hayati yang dapat digunakan untuk menjawab permasalahan-permasalahan tersebut. Salah satu produk yang kami hasilkan adalah pelet yang berbahan aktif trichoderma yang dapat digunakan untuk menggantikan penggunaan pestisida kimia, di mana kita ketahui pestisida kimia saat ini dapat mengganggu atau merusak kelestarian lingkungan.
Keinginan untuk berkontribusi serta meningkatkan kualitas pertanian dalam kehidupan masyarakat terus berkembang dan terus menghasilkan berbagai terobosan. Berbagai program kerjasama penelitian dan pengabdian tetap menjadi fokus utama untuk memberikan peningkatan kualitas kehidupan pertanian masyarakat.
Pada dasarnya seperti kita ketahui, ketersediaan pupuk buatan itu sangat sulit dan mahal sekarang kondisinya. Kemudian dengan adanya pupuk hayati ramah lingkungan mikoriza ini berarti memberikan solusi kepada petani kita untuk menggunakan pupuk hayati yang ramah lingkungan, dan ini terus terang juga akan memberikan dukungan kepada masyarakat tani, khususnya petani, agar berbudidaya secara organik. Nah, salah satunya itu dengan penggunaan pupuk hayati mikoriza.
Dalam penyelenggaraan proses akademik, sejak tahun 2016, Fakultas Pertanian sudah mulai mengimplementasikan kurikulum berbasis kerangka kualifikasi nasional Indonesia yang diharapkan mampu mendukung pencapaian visi dan misi Fakultas Pertanian, terutama dalam hal memaknai kearifan lokal, yaitu dengan mewajibkan mahasiswa mengambil mata kuliah sumber daya pertanian lokal dan mata kuliah agro-technopreneurship yang lebih menekankan untuk mempelajari dan mengeksplor komoditi-komoditi lokal seperti kopi gayo, minyak nilam, padi lokal Aceh, kemudian kerbau gayo, sapi Aceh, dan komoditi lainnya. Sehingga diharapkan pada saat mahasiswa lulus, mereka menjadi lebih mandiri dan mampu mengembangkan komoditi-komoditi lokal Aceh sebagai sebuah usaha.
Fakultas Pertanian Universitas Syiah Kuala sejak tahun 2005 telah berhasil mengoleksi lebih dari 200 jenis aksesi plasma nutfah padi lokal, termasuk 50 jenis padi beras merah yang merupakan kekayaan sumber daya genetik lokal yang sangat bermanfaat untuk masa depan. Pemberdayaan dan penelitian varietas lokal juga memberikan hasil yang memuaskan. Salah satunya adalah padi Unsyah 1 Sambarasi, diciptakan dari varietas lokal Sambai dari Pulau Simelu dengan sentuhan teknologi mutakhir.
Padi itu kita tanam, kemudian kita hentikan penyiramannya, kita hentikan pengairannya. Itu lebih dari 1 bulan, bahkan sampai 39 hari, itu tanahnya sudah kering, sudah rotak, bahkan kalau kita ambil itu sudah menjadi debu. Tapi kalau kita lihat bahwa tanaman padinya itu masih bisa tumbuh dengan baik, masih hijau, dan bulir-bulirnya masih berisi, masih berproduksi tinggi. Jadi memang kita mensimulasi perubahan iklim global ke depan itu di dalam rumah kaca supaya nanti kita bisa melepas varietas baru itu yang tahan terhadap cekaman lingkungan seperti kekeringan, suhu tinggi, seraman hama penyakit dan sebagainya.
berbagai pencapaian akademis dan ilmiah tidak menjauhkan mahasiswa Fakultas Pertanian Universitas Syiah Kuala dari berbagai prestasi lainnya. Terbukti dikenalnya nama mahasiswa Fakultas Pertanian Universitas Syiah Kuala dalam berbagai program pertukaran mahasiswa ke sejumlah negara di dunia, salah satunya adalah negara Jepang.
Jepang memberikan kami pelajaran bagaimana mereka bangkit dari keterpurukan setelah musibah yang menimpa mereka dengan menggunakan teknologi serta melakukan inovasi dan peningkatan kualitas SDM yang terus-menerus dilakukan. Mereka dapat memajukan pertanian mereka seperti sedia kala, bahkan mereka bisa jauh lebih maju dibandingkan pertanian yang ada di negara manapun.
Dan untuk terus meningkatkan kualitas, Fakultas Pertanian Universitas Syiah Kuala bukan hanya bekerja sama dengan berbagai institusi lokal dan nasional, namun juga menjalin hubungan baik dengan berbagai lembaga internasional. Meskipun secara kasat mata, prestasi dan prestise Fakultas Pertanian sudah cukup mendunia, namun sivitas akademika fakultas ini masih meyakini bahwa pekerjaan masih jauh dari selesai. Oleh karena itu, seluruh energi dan sinergi yang dimiliki difokuskan oleh fakultas ini untuk mengoptimalkan segenap potensi diri demi mencapai visi dan misi.
Perguruan tinggi sebagai lokomotif pembangunan berbasis ilmu pengetahuan, teknologi, inovasi, dan karakter bangsa. Dan pertanian sebagai salah satu sektor yang memegang peranan sangat penting dalam pengembangan ilmu pengetahuan, teknologi, dan inovasi, terutama di bidang pertanian guna menjaga ketahanan pangan. Revolusi industri 4.0 telah mengubah sistem pertanian yang efektif dan efisien berbasis smart farming seperti Internet of Things, Big Data, dengan harapan produktivitas pertanian meningkat dalam mewujudkan kedaulatan pangan. Maju pertanianku, makmur rakyatku.
Assalamualaikum. Lun sambut jame yang katruh nedega. Lun pemulihan. Bungong hai sudah bungong, hai kena netamong neja pariksa.
Bungong hai sudah bungong, kena netamong neja pariksa.
Kalau sayangnya bungong lenton, bungong kembe, bungong mangat besi, bungong jempa. Yo bungong lenton, bungong laye, bungong mangat be, bungong dahlia. Bungong hai sudah bungong, ala kena netamong neja pariksa. Bungong hai sudah bungong, ala kena netamong neja pariksa. Yo bungong lenton, bungong kembe, bungong mangat besi, bungong jempa. Yo bungong lenton, bungong laye, bungong mangat be, bungong dahlia. Amin Allah Summa amin.
Urang mumin galake-lake doa.
Berkat rahmat Allah yang beri, nangro Aceh makmu senia.
Amin Allah, amin. Urang mumin galake-lake doa.
Berkat rahmat Allah yang beri, nangro Aceh makmu senia. Lale lale gutanyo lale, ana jantate umuka tuha. Putih di janggut kuning kuning on mise, antum tak cumbe di kamu salah. Putih di janggut kuning on mise, antum tak cumbe di kamu salah. Antum tak cumbe di kamu salah. Antum tak cumbe di kamu salah. Putih di janggut kuning warna mise, antum tak cumbe di kamu salah. Antum tak cumbe di kamu salah. Antum tak cumbe di kamu salah. Lale lale lale. Lambura hai burak menari, burak menari. Lam atuh ruhung gunung. Lamba cabeng bungong, hai baca bungong. Lam ane le kuah.
Lambura bura menari, bura menari. Lam atu rung gunung. Lam baca bungong, baca bungong. Lam ane le kuah.
Sulit ke pangkai, alamu debek nak sulit beramanah dipercaya.
Sulit ke pangkai,
Kanjai ke laba,
kamu debek nak sulit beramanah dipercaya.
sulit ke pangkai,
Kanjai ke laba,
alamu debek nak sulit beramanah dipercaya.
sulit ke pangkai,
Panjai ke laba,
kamu debek nak sulit beramanah dipercaya.
bagu rahayu maha ihala, bagu rahayu maha uhele. Lambu kerlek sayang hai sayang ke tapak payung. Lama ujung kampung hai kampung ke Pulau Jawa. Lam hajat di hati sedola kata dengan lun. Hai mebulam dalung hai dalung tak bagi dua.
Dalam mempulau perahuan 32, enakan jalan tak urut di luar.
Hum lele hala bagura hum lele hala. Hum lele hala bagura hum lele hala. Ya Allah tiwa ponang rohai bule di putih. Di putih side di Aceh Raya. Hai dalam sejarahnya kala metule. Lepas tak arif Iskandar muda. Nangro Aceh metua, belega dalam dawa. Saja besar langkah bersatu tegang. Nangro Aceh metua, belega dalam dawa. Saja besar langkah bersatu tegang.
Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. We are pleased to welcome you to the 4th International Conference on Agriculture and Bioindustry, Icagri 2022, with the theme Strengthening Resilience and Adaptive Capacity on Climate Change to Promote Sustainable Agriculture and Food Security at Faculty of Agriculture, Universitas Syiah Kuala, Aceh, Indonesia.
We are pleased to invite both local and international academia, researchers, policymakers, professionals, and other stakeholders to join us at the 4th International Conference on Agriculture and Bioindustry. This conference is hosted by Agriculture Faculty, Universitas Syiah Kuala. It is an honor for us to introduce and welcome the guests at this conference. The Vice Rector for Academic Affairs of Universitas Syiah Kuala, Professor Dr. Insinyur Agussabti, M.Si, IPU.
The Dean of Agriculture Faculty, Universitas Syiah Kuala, Professor Dr. Insinyur Samadi, M.Sc.
Chairwoman of the 4th Icagri 2022, Dr. Elvira Iskandar, S.P, M.Sc. And also welcome all the keynote speakers, the presenters, and participants of Icagri 2022.
Ladies and gentlemen, before we begin our main agenda today, let us listen to the recitations of Holy Al-Quran Surah Al-An'am, verse 141, that will be recited by Mr. Munzirin. Mr. Munzirin, the time is yours.
Assalamualaikum warahmatullahi wabarakatuh. أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. وهو الذي أنشأ جنات معروشات وغير معروشات وغير معروشات والنخل والزرع مختلفا أكله والزيتون والزيتون والرمان متشابها وغير متشابه كلوا من ثمره إذا أثمر وآتوا حقه يوم حصاده ولا ولا تسرفوا إنه لا يحب المسرفين ولا تسرفوا إنه لا يحب المسرفين صدق الله العظيم.
Thank you, Mr. Munzirin. Stepping on to the following agenda is the recitation of Salawat Badar. All participants are demanded to stand up.
صلاة الله سلام الله على طه رسول الله صلاة الله سلام الله على ياسين حبيب الله توسلنا ببسم الله وبالهادي رسول الله وكل مجاهد لله بأهل البدر يا الله صلاة الله سلام الله على طه رسول الله صلاة الله سلام الله على ياسين حبيب الله.
Ladies and gentlemen, for a brief moment, we would like to invite you to sing the national anthem of Indonesia, Indonesia Raya.
Thank you. Please be seated. For the blessing of our agenda today, let us pray together, and Mr. Munzirin will be leading us.
أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. الحمد لله رب العالمين حمدا يوافي نعمه ويكافئ مزيدا. يا ربنا لك الحمد كما ينبغي لجلال وجهك الكريم وعظيم سلطانك. اللهم صل على سيدنا محمد وعلى آله وصحبه أجمعين. اللهم اغفر للمسلمين والمسلمات والمؤمنين والمؤمنات الأحياء منهم والأموات برحمتك يا أرحم الراحمين. اللهم إنا نسألك علما نافعا ورزقا طيبا وعملا متقبلا. اللهم إنا نسألك علما نافعا ورزقا طيبا وعملا متقبلا. ربنا إننا سمعنا مناديا ينادي للإيمان أن آمنوا بربكم فآمنا. ربنا فاغفر لنا ذنوبنا وكفر عنا سيئاتنا وتوفنا مع الأبرار. ربنا آتنا في الدنيا حسنة وفي الآخرة حسنة وقنا عذاب النار. سبحان ربك رب العزة عما يصفون وسلام على المرسلين والحمد لله رب العالمين. السلام عليكم ورحمة الله وبركاته.
Excellencies, ladies and gentlemen, moving on to the next agenda, we're now going to listen to the welcoming statements delivered by the chairwoman of the 4th Icagri 2022. Ladies and gentlemen, please welcome Dr. Elvira Iskandar, S.P. M.Sc.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillah, all praise to Allah. Peace and blessings be upon Prophet Muhammad sallallahu alaihi wasallam, the messenger of Allah. Honorable Rector of Universitas Syiah Kuala, Honorable Vice Rector of Universitas Syiah Kuala, Honorable Dean and Vice Dean of Universitas Syiah Kuala Agriculture Faculty, Honorable Keynote and invited speakers, Honorable sponsors, distinguished invited guests, paper presenters, committee members, and participants in this conference. Thank you for giving me this opportunity to welcome you in the 4th Icagri 2022 conference. Since 2019, we had successfully organized the 3 previous Icagri, and we are keeping hold this conference virtually this year due to the protracted pandemic. This means that this pandemic is not a constraint for us to perform the scientific meeting, as is our responsibility for the development of knowledge, science, and technology. Excellencies, ladies and gentlemen, climate conditions have recently been unpredictable. Climate change has raised global temperatures, shifted rainfall patterns, and increased the frequency and severity of extreme weather events. Climate change tends to reduce food production, which has a direct impact on farmer welfare and moreover has a significant impact on delaying agricultural development. As a result, it is critical to develop adaptive capacity in order to reduce all risks and achieve the sustainability and resilience of agricultural production system. Therefore, this year's conference theme is strengthening resilience and adaptive capacity to promote sustainable agriculture and food security. We are delighted to welcome the outstanding speakers to discuss the topic at our conference. Professor Dr. Insinyur Fadjry Djufry M.Si, Head of the Indonesian Agency for Agricultural Research and Development, Republic of Indonesia. Professor Han Jianlin, Head of International Livestock Research Institute, Chinese Academy of Agricultural Sciences, China. Professor Bhesh Bhandari from School of Agriculture and Food Sciences, University of Queensland, Australia. And the last, Professor Anna J. Keutgen from University of Natural Resources and Life Sciences, Vienna, Austria. Excellencies, ladies and gentlemen, I would like to extend hearty welcome to all experts, professors, researchers, policymakers, and research students from around the world, and to thank you for your interest in the 4th International Conference on Agriculture and Bioindustry. The editorial board received a total of 169 papers from 15 countries throughout the world: Malaysia, Nigeria, Iraq, Mexico, Libya, Belgium, Polandia, Canada, Vietnam, Korea, Germany, Australia, China, Austria, and Indonesia. A total of 135 papers were accepted to be presented in this conference, while the 34 submitted papers were rejected. All papers were reviewed by double-blind review, and the accepted paper will be submitted to IOP Conference Series, Earth and Environmental Science Index by Scopus. On behalf of the whole committee, we want to acknowledge and express gratitude to all parties supporting this conference: the Rector of Universitas Syiah Kuala, the Dean and Vice Dean of Agriculture Faculty, and the international partner of Icagri 2022. Our special thanks to our keynote and invited speakers. And last but not least, thank you to all committee members for your kind and hard work for this conference. Hopefully, the conference will highly contribute to our future sustainable development in the agriculture sector. Have a nice conference and hope to see you again next year at Icagri 2023 conference. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Dr. Elvira Iskandar. We are now going to listen upon the welcoming speech delivered by the Dean of Agriculture of the Faculty of Universitas Syiah Kuala. Ladies and gentlemen, please welcome Professor Dr. Insinyur Samadi, M.Sc.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Very good morning, ladies and gentlemen. First and foremost, we have been given the opportunity here to give thanks to the Almighty God for His abundant mercies and grace. On behalf of the Faculty of Agriculture, Universitas Syiah Kuala, let me extend a very warm welcome to all of you at the 4th International Conference on Agriculture and Bioindustry, Icagri 2022, held by the Faculty of Agriculture, Universitas Syiah Kuala. I would like to take this opportunity to express my wholehearted gratitude to Professor Dr. Insinyur Marwan as a Rector of Universitas Syiah Kuala for making this international conference possible. I honorably welcome to our keynote speakers, Professor Dr. Insinyur Fadjry Djufry, M.Si, Head of the Indonesia Agency for the Agriculture, Research and Development, Republik Indonesia. Professor Jianlin, Head of the International Livestock Research Institute, China's Academy of Agriculture Science, China. Professor Bhesh Bhandari from the School of Agriculture and Food Science, Universitas Queensland, Australia. Professor Anna J. Keutgen from University of Natural Resources and Life Science, Vienna, Australia. Distinguished guests, ladies and gentlemen, the 4th Icagri 2022 is a very strategic and efficient platform and channel for exchange and strengthen the cooperation between institutions in realizing the ideas of agriculture development. Based on this year's theme, a special meeting is needed on sustainable agriculture on bioindustry to strengthen a linkage of the government, institution, corporation, researchers and agriculture communities in order to build an adaptive capacity to climate change for the realization of the resource based on food security and local wisdom. Discussion in the thematic parallel session on biodiversity, sustainable agriculture, forestry, animal science, and other topics should provide us with the new insight into managing natural resources based on the local communities in order to strengthen resilient and adaptive capacity to climate change. Distinguished guests, ladies and gentlemen, this is the 4th year that we have holding our annual conference. Similar to the previous 3 years conference, this year's conference is also held virtually due to pandemic situation. My deepest appreciation will be delivered to the committee of the 4th International Conference on Agriculture and Bioindustry, the 4th Icagri 2022, for the commitment and dedication to the success of this international conference. Finally, I cordially invite you all to participate in this international conference. We wish you an enjoyable conference and have a good moment in this conference. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Thank you. It is our deep pleasure to introduce the Universitas Syiah Kuala's Vice Rector for Academic Affairs to deliver the welcoming remarks, and afterwards, we would like to request him to officially open the Icagri 2022. Ladies and gentlemen, please welcome Professor Dr. Insinyur Agussabti, M.Si, IPU.
Assalamualaikum warahmatullahi wabarakatuh. My peace be upon you. My dear colleagues, professors, lecturers, researchers, ladies and gentlemen. On behalf of Universitas Syiah Kuala, I would like to express our warmest welcome to all of participants on this conference. the Honorable Rector of Universitas Syiah Kuala, the Honorable Keynote Speakers, Professor Fadjry Djufry, Head of the Indonesian Agency for Agricultural Research and Development, Republic of Indonesia, Professor Jianlin, Head of International Livestock Research Institute, Chinese Academy of Agricultural Sciences, China, Professor Bhesh Bhandari from School of Agriculture and Food Sciences, University of Queensland, Australia, Professor Keutgen from University of Natural Resources and Life Sciences, Vienna, Austria. Climate change remains a global concern as it has a significant impact on human activities. The agricultural sector is particularly vulnerable to this condition. Extremely temperatures, water scarcity, extreme weather change, and increasing natural disaster have led to the land degradation and decreasing agricultural land. Climate change affects food security and lead to a global decline in crop production. Without the ability to adapt to climate change, agricultural productivity would continue to decline, resulting in economic difficulties and poverty. The fourth International Conference on Agriculture and Bioindustry, Icagri, aims to promote the interaction among scholars, researchers, and practitioners to strengthen academic and industrial collaboration, to establish effort and action to respond to the impact of climate change and contribute to the agricultural community and its livelihood. We believe that the fourth International Conference on Agriculture and Bioindustry will stimulate useful discussion and sharing of ideas from multidisciplinary researchers, scientists, practitioners, and policymakers, and will give great contribution to the prevention and solution to various problems due to these emerging issues. Distinguished guests, ladies and gentlemen, last but not least, my deepest gratitude goes to international scientific committees and editorial boards, steering committees, and special thanks to organizing committees, members, sponsors, and volunteers who have both directly and indirectly supported the organization of this conference. To all of our distinguished guests and participants, thank you for participating in our virtual conference. Finally, allow me to declare the fourth International Conference on Agriculture and Bioindustry, Icagri 2022, is officially opened. May our God always guide and bless all of us. Amin. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Professor Dr. Engineer Agussabti, M.Si, IPU. Distinguished guests, ladies and gentlemen, we will now begin the first speaker session that will be moderated by Professor Dr. Engineer Darusman, M.Sc.
Professor Darusman is a lecturer and head of Biochar and Forest Conservation Research Center, Universitas Syiah Kuala. He was born in Icagri, 9 October 1962, and finished his bachelor degree at Universitas Syiah Kuala. He then pursued his master's degree in 1990 and received a PhD in 1994 at Kansas State University, United States of America. Ladies and gentlemen, please welcome Professor Dr. Insinyur Darusman, M.Sc.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. May Allah SWT bless us always. I am so honorable to be a moderator for these two distinguished prominent presenters today. That is Professor Fadjry Djufry and Professor Hans Jianlin. Both these speakers will talk about the climate change effect to our human activities. And topics is addressed to external point of view and also internal point of view. The external point of view will be delivered by Professor Djufry, and internal point of view will be delivered by Prof. Hans. Therefore, the seminars are very important. Then allow me for the next 1 hour to chair this promising webinar. Due to the time constraints, we need to agree before we start that each presenter will deliver for 30 minutes. Then after the two speakers finish, we're going to have discussion for another 20 minutes and then the conclusion. Let me read the first curriculum vitae for the first keynote speaker. Name, Professor Dr. Fadjry Djufry. Current position is Head of Indonesia Agency for Agricultural Research and Development, or Balitbang Tan, or Balitbang Pertanian, since 2019. Djufry was born in Makassar on March 14, 1969. He got his master's degree in 2000 and doctoral degree in 2005 from IBB University, majoring on agriculture climatology and plant modeling. During his career, he has been acting as a director for ICECRD during 2015 until 2019. As a head of Sulawesi AIAT, or Indonesian Assessment for Institute for Agricultural Technology during 2012 until 2015, and also other tasks were conducted by Professor Djufry. Djufry also got involved in the university as a postgraduate lecturer at Makassar Islamic University and Hasanuddin University, and then Lambung Mangkurat University. On January 25, 2022, he was inaugurated as the 630 National Research Professor and the 159th Ministry of Agriculture Research Professor in Indonesia. Wow. Recently, he was appointed as JIRCA's Scientific Advisory Board in 2022. That's all about his CV. Today's speech titling about strategy and program from agriculture sector facing climate change to promote food security. Ladies and gentlemen, all of a sudden, the Indonesian President Jokowi requested him that he attend the G20 in Rome under the Office of Food Agriculture Organizations. Therefore, at this meeting or at this seminar, Mr. Djufry will represent Dr. Asma Hansa under the same office, Balitbang also. Dr. Asma Hansa, hello. The stage is yours for 30 minutes, and then we'll follow the second keynote speaker, and then we'll have discussion for another 20 minutes. Let's welcome Dr. Asma Hansa.
Okay, thank you, Moderator, Professor Dr. Darusman. Can you hear me clearly?
Sure.
Yeah, okay. Honorable Vice Rector of Universitas Syiah Kuala, Professor Dr. Agussabti, Dean of Agriculture Faculty, Professor Dr. Samadi and Vice Dean, the Chair of the 4th Icagri, Dr. Elvira Iskandar, Keynote Speaker, Invited Speaker, Researcher, Policymakers, Student Presenter. Ladies and gentlemen, Assalamualaikum warahmatullahi wabarakatuh. Good morning, pleasant day to you all, and Prof. Darusman, today our DG, Professor Fadjry Djufry, and our Director of Icagri is traveling to Rome, Italy, to attend the invitation from FAO on the Chief Scientist Roundtable. So our DG will share the role of science and innovation for SDG 2. SDG 2 is zero hunger. And that's why I was assigned as speaker for this Icagri this morning. And this morning I will be presenting the strategy and program from agriculture sector facing the climate change to promote food security. Let me share the screen. Yeah, this is the topic I will deliver. So I will be presenting this strategic and program from agriculture sector as in the climate change to promote food security. Next, this is the outlines. We start from the global climate change phenomenon. Then the position of agricultural sector is shape on climate change and how climate change impacts on agriculture sector, and then we will discuss regarding the main goal of agriculture development. We have food security, we have adaptation and mitigation strategy. Then we will discuss also regarding the adaptation action program. This is the priority and the closing. Next. All participants, ladies and gentlemen, so this is the phenomenon regarding the global climate change. From this is rising 1.5 degrees Celsius, and on 2100 it projected 2 degrees Celsius. So this is the phenomenon already recorded by the IPCC and others bodies. And from this phenomenon, we can see for Indonesian case, the sea level rising in Indonesia is around 3.9 mm per year. And then the IPCC also reported that the sea level rise is projected up to 60 centimeter during 2000 until 2100. So that's why we can also see the fact in the field that in Jakarta the intrusion already reached 11 kilometers. What about the agriculture? Rice field losses in West Java around 12,000 hectares. That is because of the 50 centimeter of sea level rise. So, and then the production loss also affected by the flooding and also the salinity. Next. And this figure shows us the beginning of rainy season and the dry season. So from this historical data, the beginning of the dry season is become more advanced, and the beginning of the rainy season is retreating. So this is the impacts on our agriculture. It is projected that in the period the source of greenhouse gases also as a victim. So the source of greenhouse gases from the rice field, livestock, and also from the wetland. And then that's the source. But also we are victim from this climate change. There are flooding and then also drought, also pest, and this is attacks and also salinity. But another side, agriculture sector also able to reduce greenhouse emission. So this is the position of agriculture. Next. So agriculture sector as greenhouse gases from the wetland, rice field, and also livestock. Next, we can see this is the source of the gas emission. Paddy field, there is methane, and so also N2O from the nitrogen fertilizer, and also from the animal bumping, enteric fermentation from the animal. There is methane. And also methane and also N2O from the Keutgen. Next, besides as the source of the greenhouse gases, in the agriculture sector also act as the thing. So here this crops will be the sink for the greenhouse gases. And there is the data from monsoon last year that intensification of oil palm and allowing expansion only 50% of business as well expansion to the area with low carbon stock. So it will save 2.6 million. Next, and this is the business as a whole projection and greenhouse gases emission reduction from each sector. From this figure, we can see that agriculture sector has the contribution smaller compared to the other sector, but this is our concern. Next. And this is the NDC of Indonesia last year, National Determined Contribution. So with intervention by conditional mitigation scenario, CM1, CM2, it will be different. And nationally agriculture sector contributes around 8% emission in total. Next. Then this is the presidential regulation number 98 last year regarding the economic carbon value, or in Indonesia nilai economic carbon. To support this presidential regulation, Ministry of Agriculture has identified 3 programs. The first one is optimizing smallholder oil palm plantation through sustainable oil palm plantation or sawit berkelanjutan program, and then rehabilitation of abundance land through planting the tree with high carbon stock such as fruits and plantation crop. So when we choose the fruit crop, so we prefer to the tree fruit crop because it can storage the carbon. And then the third is rehabilitation of Phechu in West and East Nusa Tenggara. Next. And this is climate change impact on agriculture, as I said earlier. So there is changing in rain patterns, also high on extreme variability and extreme dry and wet climate event will be more likely to be above normal. And this increased recitation and psychological change in rice plant, it will increase the potential for the decreasing rice production. So the climate change impact is very real and significant in agriculture sector. Next. So here the loss of production because of the decreased land use area and also the salinity. We can say that in West Java is almost 160,000, and this figure will tell us that this is the impact of the sea level. The sea level rise, and then the sea level rise will affect to the total land area for agriculture. Also, it's bring the salinity. Next. And our planning board, national planning board, already calculated the economic loss due to climate change in all sector, from the coast, N.Si, from the water, from agriculture, and also the health sector. We can see that the total potential loss, economic loss, around 545 trillion, and agriculture is around 78 trillion, and this is to decrease the economic loss in agriculture. There is a two scenario. So business as well in red line, and also with intervention by climate resistant development. So by intervention of innovation, the economic loss will be decreased until 16 trillion. Next. Then we will discuss regarding this main goal of agriculture development. Of course, we know all that the main goal is to improve food security and sovereignty. This is the number one. And the second is increasing the added value and competitiveness of agriculture product, and then increasing the supply bio-industry and bio-energy raw material, and increase farmer income and welfare. So food security and safety is a priority for agriculture development. We know that agriculture is vulnerable to climate change, and agriculture is also sort of greenhouse gases. So our agriculture development prioritizes the food security. Next. And Indonesia position actually for the agriculture sector in climate change is in line with the COP26 last year in Glasgow, that the strategy for agriculture development are adaptation is the priority. So from the adaptation and mitigation, so adaptation is the priority. So we have the main goal of the agriculture development. And it is expected that with adaptation, we also has a benefit on emission reduction or mitigation as co-benefit from the adaptation strategy. We can see next. This is the several adaptation activities that give co-benefit as mitigation, among others. For example, balanced fertilizer. So with balanced fertilizer, So the intervention through balance fertilizing, so growth and yield of rice crop will increase. And another side, the emission from the fertilizer decrease. That is the co-benefit from the adaptation, intervention, and that is as mitigation. So the mitigation, the mitigation can gain from the co-benefit from this intervention. Also for like alternate watering and drying and field rice also through this intervention with the same water availability, the planting area is higher and the co-benefit is methane emission decrease. Next. And this is the, we already discussed that we have main goal of agriculture development, and then we prioritize the adaptation, and this is the adaptation action programs as priority. The first one is rice variety, balance fertilizing, water saving technology. Here is alternative watering and drying, system on rice field, and water table management on wetland, improving feed quality, application of cropping calendar, providing water storage, among other pond, ditch, supplement irrigation, etc. And application of soil and water conservation. Next. Here, Ministry of Agriculture already released many rice cultivar from 1950 until now. Next. And then this is new rice cultivar for facing the climate change. So with the characteristic for early harvested, we have the variety for drought, acid soil tolerant. We have the variety also for the submerged tolerant, and also the salinity. And for the pest and disease, we have the variety. So this is the rice cultivar can be used to facing climate change. Next. And different ecosystem, we also already classify the rice variety. For rainfed ecosystem, upland, swampland, saline land, and also highland. Next. And this is like I mentioned previously, this is the cultivar with the cultivar for facing the pest and disease. And we also already developed the Impari ear nutrizing. This is for stunting problem solution, and it's contain around 35 ppmz, and that fulfill 1/4 of daily human needs. So this is very important from the Ministry of Agriculture. Next. For fertilizer recommendation, we already released fertilizer recommendation for rice field, for NPK. Also we release for corn and soybean, and this is until the this sub-district level. And this balance recommendation of course already determines the nutrient status in the soil, also the nutrient needs by the crop. And also we develop all recommendation for horticulture crop and also for estate crop. Next. And alternate the wetting and drying also one of another adaptation can be used for climate change situation. Next. And water table management on peatlands is very significant in reducing the greenhouse gases from this graph, we can see that before and after wettings, there is a difference in the greenhouse gases, CO2, and there is a decreasing in after. Next. And also we have the improving feed quality, and in our agency we have already many collection of the grass. Next. And this is integrated cropping calendar. This is verse 3.3. Then using this system information, so we will know when's the time, when's the schedule for plants arise, and this information system already into the sub-district level. Next. The water storage, this will anticipate for the water availability in the field. Next. Okay, next. And ladies and gentlemen, soil conservation has a co-benefit as mitigation, because through intervention of this soil conservation, then it will suppress the loss of carbon, organic carbon of soil. Also the vegetative technique, so it will add organic carbon in the soil. And the mitigation, the co-benefits we have from this intervention will be the reduction in C2O emission, also reduction C2O and emission and sequestration CO2. Next. And so this is just the picture for the mechanical conservation technique. Next. And this is the vegetative soil conservation technique can we implement in the field. Next. Now, this is the, ladies and gentlemen, this is the achievement of mitigation from agriculture sector in 2021, last year, and this is around 13.9 million tons CO2 equivalent. We can see here in the right side that this can be achieved, the mitigation for agriculture, through the action or program. And this program is delivered by Ministry of Agriculture from the biogas. UPO is unit for organics fertilizer. And then also we have program on organic village, and we also introduce the low emission rice variety, enhance the feed for the animal, and then balance fertilizer and water tables management for. So we can see here that this action or program is seeking emission reduction, and here we can see that the achievement of mitigation greenhouse gases emission in the agriculture sector in last year 13.9 million ton of CO2 equivalent. Agriculture sector has said the agriculture national development contribution NDC target last year, which is smaller than next. Then we come to the climate change impact on agriculture sector need to be anticipated by various innovation and strategic program. And the main priority of reducing emission concept in the agricultural sector is food security, so that adaptation action is more productorized and mitigation as the co-benefit of the adaptation. and the commitment and implementation of innovation on climate change adaptation is very important and really needed to promote food security. That is all from our presentation. Thank you, Prof. Moderator.
Thank you, Pak Dr. Harmansyah. It's really interesting. Yeah, it's really interesting. Noted one statement that agriculture is the source of greenhouse gas emissions. Yeah, but agriculture also vulnerable to climate change, or agriculture also the victim of the climate change. That is very the contradiction statement, right? Okay. However, we will discuss it after the second keynote speaker delivery. Next, we go ahead to the second keynote speaker that will be delivered by Prof. Jianlin. Thank you, Pak Dr. Harmansyah. So please bear with us for another 30 minutes. Thank you. Ladies and gentlemen, the next keynote speaker will be delivered by Prof. Jianlin from ILRI Case Laboratory in China. Hello, Prof. Hans.
Yes,
how are you doing,
yes,
Prof. Hans?
I'm here.
Okay. Okay. Okay, it is an honor for us you be with us for this webinar, and we really expect that you can share your current research, and also that I noticed there will be a little bit similar to the previous seminar about the climate change adaptation also. Ladies and gentlemen, let me read the CV of Prof. Jianlin. Names Prof. Jianlin. The current position is the Senior Scientist, International Livestock Research Institute, and also he is the Professor in Animal Genetic, Institute of Animal Science, Chinese Academy of Agricultural Sciences, CAAS, Beijing, China. Professor Hans got his PhD degree majoring in ecology at Lanzhou University, Gansu, China, during the 1997 until 2000s. Then, during 1980 until 1984, he got bachelor degree in animal science at Gansu Agricultural University, Gansu, China. His previous work, from 2001 until present, he is a postdoc scientist and also senior scientist at International Livestock Research Institute, Nairobi, Kenya. 2005 until now, he is seconded by ILRI as the jointly appointed principal scientist to work at CAAS ILRI, sorry, too many abbreviations, Joint Laboratory on Livestock and Forage Genetic Resources at Institute of Animal Science, Chinese Academy of Agricultural Sciences, Beijing, China. Today, Mr. Hans will share his research, or his current research, titling Genomic Architecture for Rapid Adaptation via Long-Term Natural Selection within and or Historical Integrations between Livestock Species. Then, for time constraints, let us welcome Prof. Jianlin for another 30 minutes. Time is yours, Prof. Hans.
Okay, yes. Good morning, everybody. Thank you for this very detailed introduction from our moderator of this plenary session. It's really my great pleasure to join this important event again. At this time we shifted our focus on the climate change at the Association of Agriculture. So you can see from my presentation here, based on Dr. Asma Hassan's, the presentation on the climate change and its impact on agriculture sector. I will be focusing on what to do with the livestock production. Compare with what we heard just a moment ago, where you see the rice research is much advanced compared to livestock. Where we have many variety of rice to be, introduced to different production system to adapt to the climate change. While we do not have a single breed of livestock to adapt to climate change so far. This is therefore we need to do a lot more research to understand what's behind, this adaptation of our livestock species. We heard a moment ago the issue of climate change. Climate change definitely has a significant impact on the livestock production, while we are receiving less rainfall but high temperature. The livestock can be significant, affecting particularly for the smallholder livestock keepers in the developing country, while for the industrialized livestock production seems to be okay, because we can provide the housing facility to these improved livestock, while the indigenous livestock kept on the rangelands or by smallholders, they are really affected by climate change. There are two ways. One side we heard already, the agriculture, in particular livestock sector, has been contributed to climate change by the methane or carbon emission. On the other hand, this increasing temperature, reduced rainfall, or reduced crop production in certain area, we have a definite negative impact on the livestock production. We can see, yes, in the most of the developing country, the demand for animal source food, for example, the livestock, meat, milk, or egg, this demand is increasing over the last 20, 30 years. But climate change, unfortunately, come into our, the area, become really a major threat to the, the extensive livestock system, where where indigenous animal breeds still play important role in Asia and in Africa. Among these, the major the indicator of climate change, the rising temperature is number one. With the heat stress, which can lead to a reduced milk, meat, egg production, and also definitely the reproductivity and immunity of our animals. If you look at it, the industrialized livestock production, where we have the broiler or the modern layer chickens, they are kept in-house. Seems they are not directly affected by the temperature outside, because we are providing, even air-conditioned house to this modern bird. But yes, if crop production is affected, we will have a much serious competition from our livestock compete with the humans for same kind of food or crop, and also the drinking water This is really a major issue. On the other hand, yes, we heard already livestock production from both, say, the smallholder up to the industrialized system. We are, say, making a significant contribution of the methane emission. And this is really the schedule of livestock production. You know, we hear the cases in the developed country in the north, where the young generation then start to stop eating meat. If they don't want to eat meat, then we are finishing our business of livestock production. So you can see here, we are still on the left side, so this is how the climate change and all the environmental stresses affect livestock. Say, you know, because, you know, the livestock, if there's no clean enough drinking water or enough food or grazing land, definitely, you know, the growth performance will be affected. On the other side, as the organism, as the animal, you know, similar to crop, we have many breed of livestock species. The different breeds, they have been adapted to different, you know, environment, where they also developed, say, adaptive mechanism to mitigate the sort of the impact from climate change. This is what we need to do more research on livestock to understand how our different, say, species of livestock or breed can react, can adapt to the changing climate and environment, and also, say, the new management conditions. From here, I will give you a few examples of, you know, the research we have been doing on the understanding of, you know, the how the different livestock breed can say how they adapted to the different climate environment. You can see here we are keeping one livestock, say the sheep, in very different environment, from in the desert area where it is dry, cold, in the winter, hot in the summer, up to the high altitude around 4,000 meters high on the Tibetan Plateau in west part of China. We still have people at livestock living up that high altitude. This is really a sort of extreme environment of livestock where, you know, people, we have been occupy different sort of the habitat over many thousand years, and then we're supported by different breed of livestock. So to do that, we need to using the modern, say, the genomic approach. We are referring here to a population genomics analysis, which is tools we can say to genotype many genetic loci and many individual animals at the same time. This is very different from early generation of genetic study, which, you know, that time 20 years ago we were able only to working on one trait, only say 1, 2, 3 say genetic markers with a limited number of samples. But today we are moving into a population genomic era. We have SNP, say genotype chips, what we call the micro. We have say the second generation, third generation genome, the DNA sequencing method, which allow us to generate, you know, the whole genomic data at short time at also very low cost. This is really the very rapid sort of development in the last 20 years in the genomic area we are referring. The first study we did is a sort of a global sheep genomic data set. We genotype up to 74 sheep populations across the world using a 50 SNP chip, 50, which means we can genotype 50,000 single nucleotide polymorphisms among these 74 sheep populations, which can be almost 2,000 samples in that time. Then we were able to collect the climate and data over the last 40 years, for example, from 1961 up to 2001. There are several sort of the climate data available in the public databases, including the annual temperature, the rainfall, and the relative humidity, etc. So these are all the data we can retrieve from public sources. From here, we are trying to build a relationship between the global environment parameters and also the sheep population across the global. We are trying to build the relationship, say what is the, why there's so many sheep population in so different environment? Is there any relationship between the sheep breed distributed in particular environment? You can see based on the genetic data of from the genotyping, we were able to divide our sheep population into different groups from these 74 populations, and then they can also further divide it based on the climate data into the two groups. Because to understand or screening the genomic region and the natural selection for adaptation to different environment, we need to use a case control sort of study method. By dividing all these sheep into two groups, we can compare, say, one group of sheep to another group if they are living in the different environment. Then we can screen the genome as what we did here. We were able to identify many genomic regions. In each genomic region, there could be, say, a particular gene behind linking into this genomic region on different chromosomes. For example, we were able to identify up to more than 100 candidate genes in this case, which seem to play a role of the climate-driven selection. Because these are all the indigenous breeds, which basically form the following, mainly the natural selection. By extracting these candidate genes, we have a first hand of candidate to validate which of these genes are playing particular role, for example, to cope with the high temperature as the heat stress, or to adapt to the cold condition or the high altitude. This was our first study. We published more or less 10 years ago. This was really a very interesting analysis to allow us to build a relationship looking at the genetics and the climate parameters. From there, we move into our, say, the next study, looking, say, using the whole genomic sequencing data of all the indigenous sheep. You can see here, we have already many indigenous sheep, like, say, in Java, we have Javanese Sintail, we have many different sheep breed also in the tropical Indonesia, while many more breeds are found in the north. For example, you can see the sheep with this very large tail or the large run where the animal are able to store fat over the good season in the summer, and this fat can be motivated as the energy source to survive them over the cold winter. So we did, in this case, we have a focus in all the different environment within China, because that time we had a limited access of the samples outside China, but we had a very intensive sampling of indigenous sheep in China, where we have sheep sampled from desert area up to the high altitude in the Tibetan area. We compare, in this case, the Tibetan sheep at high altitude with the other group of sheep in the low altitude, so that we can identify the particular genomic regions for adaptation in the high altitude, or in the case of desert adaptation. We also using the same approach to compare sheep in the desert area to the sheep in the high humidity area. So using this approach, you can see we screen the genome of sheep. We were able to extract or identify many potential function genes, which are either, play a role for high altitude adaptation in Tibetan sheep, or in the desert adaptation of sheep in the desert area. So we have, again, another 100 more candidate genes for the adaptation of sheep to high altitude or to the desert condition. So this is a sort of analysis we did earlier. This is, we're looking at what is the genetic potential within a species of sheep, where we have many different kind of breed living in different environment. What is the role or the impact of natural selection to develop, this sort of adaptability of different sheep breed? From here, I will give you a next example of this. After examining within species genetic variation, during this analysis, we were able to identify there are some sort of the new genetic variation coming from other species of wild sheep. These sheep, they're relative of domesticated sheep. So seems to us that there was sort of specific hybridization between the domesticated sheep and the wild sheep species. Following that sort of the hybridization, there could have been sort of what we call a genomic integration from one species into another. This may be a way also to develop a sort of adaptive evolution in our sheep breed. So we did the analysis of Icagri sheep. This is a wild animal living in the high altitude in the Himalaya area. And we compared the genome with the Tibetan sheep, also in the high altitude, but they are domesticated animal. Based on the analysis, we found that there was sort of historical sort of hybridization between the Icagri and the Tibetan sheep. Following this, and there have been some natural selection. Some of the advantage areas from Icagri has been maintained in the Tibetan sheep genome. For example, one of the genes we found is the FP2 gene. This is the gene responsible for the horn size of the sheep. We know, yes, the wild sheep, they usually has a much bigger horns. A big horn would provide the rams for a stronger, say, the fighting ability. At the end, they can say, through the fighting with other males, they can occupy a better and a larger, say, the territory, and also they can definitely control more ewes as a sort of for mating. So this is the one way we looking and say, yes, seems the Tibetan sheep, they acquired these sort of the advantage area of this gene from Agali. By doing so, which may be, say, equip or enhance, say, the fitness of Tibetan sheep so that they can get more food resource, and they can pass on these better genes into next generation. Over time, this definitely improved the adaptation of Tibetan sheep to the high altitude. And similarly, there was also an integration of the hemoglobin gene. We know hemoglobin protein is very important for oxygen transportation for all the animals, where, say, to adapt to high altitude where there is the less supply of oxygen, animal need to have a better, say, hemoglobin area or hemoglobin variety to be able to transfer more oxygen in that environment. We found similarly, the Tibetan sheep also acquired advantage area from the Agali integration. So I think I don't need to go to the detail. We extended our analysis from the single wild sheep species of the, say, the Agali sheep into more wild sheep species, because we know, say, for the sheep family, there are many wild species. We only domesticated the orientalis, the wild sheep, into the domesticated, but there are many wild relatives. These species, they can all, say, hybridize between each other. Therefore, they are producing certain level of fertile progeny. By doing this, there seem to be more genetic integration from other wild species. We can see this is the distribution of different wild sheep species. Sympatrically, this is area there we have also many domesticated sheep populations living around. We did genotyping of these wild sheep and the sympatric domestic sheep populations using the SNP chip, and also we did the whole genome sequencing. Similarly, we found more sort of integration from different wild species into our domesticated sheep. At the end, you can see from here across each chromosome, we can see the is a different level of contribution of the integration from different wild sheep species. Apparently, the European mophilon, the Asiatic mophilon, the Uran, the Agali, these are the four major wild species living around our domesticated sheep. They all made a contribution through, say, what we can call adaptive integration to domestic sheep population. We can see the different species contributed different number of integration events. At these integrated areas, they are all impact on, say, the different biologic process, which, say, can enhance the fitness of different breed live in different environment. So similarly, we have stem sort of finding in the cattle species. We know, say, yes, for domesticated cattle, we have taurine, we have zebu cattle, we have Goya, we have Batin, the Bali cattle in Indonesia, and we have yak and buffalo. These are all the bovine species. Some of the species, they have a chance to hybridize each other. So this is similar to the case of sheep. We found to say yes, people they already published in the last few years. One of the example is the integration of pooled locus from taurine cattle into the yak. Otherwise, most of the yak, they carry horns, but by follow this hybridization between the yak and taurine cattle, this pooled trait has been introduced into the domesticated yak populations. And we scan the genome for integration. We can see only some chromosome genomic region on some chromosome. For example, in the case of Tibetan cattle, we found the introgressed signal on the chromosome 18 and chromosome 28. So they are only concentrating in particular genomic region, not to say this introgressed allele spread across genome. This is not the case. Follow the hybridization. In the first few generations, definitely the genes of the two species are mixed up, but over next generation, over 1,000 years of adaptation, by natural selection, only a few specific alleles from one species are sustained in another recipe species. So that's what we call the integration. We found to say yes, at mitochondrial level, the Tibetan cattle carried some yak mitochondria, and similarly, in the Tibetan cattle genome, there are particular genomic region seem to be alleles derived from yak to support, say, the Tibetan cattle for high altitude adaptation. Otherwise, we know, say, the cattle were domesticated from species living at a relatively low altitude, while the yak are live at high altitude. This is a way to quickly enhance the adaptability of, say, the Tibetan cattle, while we humans move the cattle from low altitude to high altitude. And similarly, there could be also integration from Bali cattle or from Batin or Bali cattle into the M.Si cattle or the zebu cattle. This is the way to, say, further enhance the adaptation for heat stress. In particular, this can be something interesting for Indonesia if we explore the genome of, in this case, the Madura cattle around. And this sort of, say, the interspecies adaptive integration is quite common. In humans, we notice there are many more publications in the last 5-10 years. Through, all the modern humans, we are all coming from Africa. On the way out of Africa, we come to Asia or to Europe. There have been different, say, the Homonian species. For in this case, a Neanderthal sort of integration into the modern human. This sort of the integration from Neanderthal has contributed to the specific allele for humans to adapt to the North atmosphere, in this case more in Europe. And we have also the other local human integration. I think there is something in the South Pacific Ocean for in the human study. So at the end, we say yes, the wide integration has provided sort of, say, the a mechanism to shape the adaptive genomic landscape of domesticated animal or the humans by changing our biological process for morphological adaptation, behavior, physiology, neuro, endocrine, blood, metabolism, cellular, say the different breed in different environment, then we should be able to fix a particular genotype which is adapted to a particular production system or the environment. This is otherwise, without this genomic marker, we will be continue to mix up again our generation of our genetic resources. We know that without a fixation of a particular genetic combination, the animal farmers kept will be segregating of the animals all the time. They cannot predict. They cannot predict what they will have in the next generation. So by using the genomic marker, we will be able to quickly develop a new breed or new genotype fixed, at a certain genomic proportion with good adaptation. And say yes, by doing the genomic research, we can deliver to local farmer a sort of a new breed for substitution. We can also optimize the way how we should carry on the crossbreeding program, and we can continue to do within breed selection. If we believe our indigenous breed has a unique, niche value, we should continue to do within breed selection. Then we can, at the end, using genomic marker to improve them into an improved breed. And at the last, by having the particular gene, particular mutation, today we can use a modern tool, what we call the genome editing, to manipulate a single mutation across the genome, so that we can come up with a new breed or new type of breed. This is really the modern era, I think in the next 10, 20 years. Most of the developed countries, they will come up with more genome-edited breed. And in developing countries, we have to think how we can catch up this new development. At the end, I think, yes, thank you for your attention. Thank you for listening my a short introduction of the livestock adaptation here. Thank you.
Thank you, Professor Hans. Really wonderful. It's really wonderful. I noted some statement here. Livestock contribute to and is also affected by climate change, right? And population economics approaches are being searched and researched. And economic integrations increase economic variations. Of course, all this will cope the climate change effects to the human activities and also the human life. Thank you very much, Mr. Hans. It's really appreciate for your time and for your contributions. Thank you. Ladies and gentlemen, so we are done with the two keynote speakers. Now let's go into the discussions for another 20 minutes. Before we start to the discussions, let me set up the SOP first, right? So there are two lines for the discussions through the by raising hands and also by putting your question in the chatting rooms. So we will, of course, due to the time constraints, we will request for the short and clear questions and address to who the question will be addressed to. And then let's start. Number one is there any questions for the raising hands and also for the chatting room? Okay, there is one here. The raised hand from Ibu Nur Hidayah. Ibu Nur Hidayah, the question is for speaker number 1, is for Mr. Djufry, or in this regard is for Dr. Hasmarin. The question is, what kind of forage for ruminant feed is being developed by Batlit Bangtan to reduce methane emission from livestock? Thank you. And then the second questions requested from Mr. Agus Halim. Papa Agus Halim, dear sir, Aceh has peatland ecosystem are called Rawatripa. The main problem, the status land is still not yet become the conservation area. That because there are big palm oil plantation operated. It is called APL or other use land there. How to conservation the area in private land, especially that have greater 3-meter depth for peatland. Kuala University already have suggested those area to become natural laboratory by using S.T.P approach to protect natural genetic there, flora and fauna, that may be still not know about the genetic benefit in future. Please, you would like to describe about this for us. It's long questions. I'm not sure whether the question is clear or not. But this is the questions, both questions for addressed to Bapak Prof. Djufry.
Okay. Thank you, moderator.
Yeah.
You notice there are 2 questions in the chat room for me. The first question is from Bu Nur Hidayah, and then the second question is from Pak Agus Salim. Bu Nur Hidayah asking about the forage developed by IARD. So yes, that is very important. That's the enteric fermentation or animal bumperings will release methane gas, and this animal burping or enteric fermentation is depend highly on the feeds they got, the forage. So that's why for this IARD actually already developed several forage like odot, indigo vera, then biograss, legume, rumput gajah, and other. And this feed for the animal must be combined with the concentrates. So there are many commercial concentrates in the market. And then so the second question is from Pak Agus. This is actually this is the authority of the Ministry of Forestry and Environment to handle this situation. And but that is true that when peatlands more than 3 meter depth must be conserved, and here we from IARD, if there is there is a from Ministry of Forestry and Environments want to know the depth of the peatland, then that is our authority to ground check and then make it reports to the Ministry of Forestry and Environment. That is my answer for this question, Prof. Moderator.
Okay, thank you very much, Pak Dr. Hasmaransa. I think it is clear. And then the first question is answered clearly. And the second question, actually, this is very suitable for Directorate of Lingkungan Hidup or Kehutanan to answer these questions. Okay, thank you very much, Bapak Dr. Hasmaransa. And then I open also for the chatting room's questions. Are there any questions from the chatting room?
There is one hand from Moderator.
Oh yeah, from, I didn't see that. Sabam Malau, okay. Professor Dr. Yusuf Sabam Malau. Okay, go ahead, Pak Prof. Sabam.
Yeah, thank you. Thank you very much, Moderator.
Yes.
I appreciate the presentation from both keynote speakers. The problem of the word they will resolve. But I think that some kind of thinking must be enter the paradigm of both of you. The first is arrogant of sectoral. In the beginning, I see that agriculture faculty of Kuala University had a very promising genotype of dryland paddy. You know that even the topsoil was very, very dry. The promising genotype of dryland paddy still growing. So how did the government cooperate with this agriculture faculty of the USK? How they support it? So in Indonesia, there's a problem. Arrogance of sectoral is very high. They think that they are the best. However, in the other university, there are very much research that promising to overcome this climate change problem. And the second is for Jianlin. Sometimes if you cross in agriculture, we say that it's a specific breeding. If you cross the different species, it is not good for the belief of the people. You know that maybe in the animals also like that. So you cannot use the philosophy of the intercropping, crossing between species to overcome this problem in the world. So agriculture is only a victim. We see that that Kyoto agreement, the USA is not agreeing for that. So CO2 was produced very much from industrial sector. So agriculture is only victim. But it is good that mitigation is not the solving way. Adaptation is the solving way. I agree with that. Thank you very much. I'm sorry if my question is not so clear. I hope the question is good enough to understand.
Okay, thank you very much. Thank you very much, Prof. Malau. And then these questions will address to each of you. Pak Asmaransa, about the networking with the Faculty of Agriculture, and then for adaptations of the mitigations, and then also Prof. Hans about the victim that the agriculture is the victim especially. So what is your opinion on these ones? Please, which one first, from Prof. Hans or Bapak Dr. Asmaransa, to respond this statement from Professor Malau?
Prof. Hans.
Yes, please.
Okay. It's an interesting question. Definitely, I see I hear the early also the comments for agriculture. I think we need to develop, say, a different policy, technology, and also the genetic resources. One side, say, to mitigate, to reduce, say, the carbon or methane emission. On the other hand, we have to improve productivity. And to improve productivity, this is definitely the concern. I think in the developing country, often, you know, from what I observe, say, from government side, say, the policymakers seem to take a easy and standard approach. Say, yes, let's go to disseminate one rice cultivar in this case. Say yes, because people believe that this is a high yielding cultivar, they have a good quality, but often they forgot if this say single or a few cultivars are able to cope very different environment conditions, across the country. We definitely see from Sumatra down to Java, for the east, the climate change, the environment is very different. Even say, yes, you may have a similar environment, but people are also different. We have a different scale to implement, to use all the technology. We have to keep the mind, to allow, the diversity of people, technology, policy, and then the genetic resources, because each place, each system, they could have definitely optimized sort of production. This is we need to keep in mind and say in the country. I see he also said the local universities, they do play a unique role in this case to be better understand the local environment, what variety should be disseminated here, there, based on the, the training, the extension, or in the local environment, local setting. And similarly for the livestock, say yes, we can say to do more research to understand what's the contribution from different species. And today, because we are not necessarily say going back again to hybridize these two species, other than say yes, if we know the particular gene, particular variation which say made this contribution, then we can using molecular marker, using and also the genome or gene editing to target the specific the area for manipulation, instead of going back to hybridization or crossbreeding, which definitely what I said is a way to mix up everything from both parents, and it's very hard to spend that long time over many generations to say to narrow down or to fix a particular combination of the genes, the alleles. I think we have to using say the modern tools to manipulate the particular genomic region, or to operate on a single mutation by gene editing. So this is, I think, the way we go. Thank you.
Okay, I guess it is clearly answers by Prof. Hans. And the next question addressed to Dr. Hasmaran Shah. Is there any response on that one, please? Ava?
Yeah, okay, thank you, Prof. Darusman. I'm sorry if I missed the question from
Professor Malau.
Malau, yeah.
Yeah.
regarding the networkings amongst the sectors. In our case, for example, when we are asking to ground check for the peatland DA for agriculture or other purposes, we as regulation stated that we must involve the local university and then also the local agency for forestry. And the new regulations, we also must involve the person from the Directorate ecosystems of peatlands. So then for the climate change itself, in the national level, we are under coordination of Ministry of Forest and Environment, and we always submit the target for NDC in agriculture sector. Also, we must annually report the mitigations we achieve. As I present in my presentation, that is the mitigation for last year. That is my response, Prof. Darusman.
Okay, thank you very much, Bapak Dr. Asmaransyah. Now there is the last questions from the chatting rooms addressed to you, Bapak Dr. Asmaransyah. Is there any life cycle assessments for the planting process? Can you just answer briefly? Is there any life cycle assessment for the planting process?
I cannot got this question.
Yeah, I don't have it.
Can you elaborate what you are asking about the life cycle assessment for planting processes?
Can we call Ibu Alaili? The question is there any life cycle assessment for the planting process? Alaili, can you come up? Alaili?
Yeah, okay, thank you.
Okay. Can you elaborate a little bit? Please.
I just want to know how is the effect for the economic, social, and the environment. Just three of the effect for the planting that spring. So the three aspects. Thank you.
Okay, thank you. So three aspects you mentioned is for sustainable development, right? From economic, social, and environment. So in related to the climate change, so for example the balanced fertilizer, it's already involved this aspect. From the environment, the balanced fertilizer will reduce the greenhouse gases emission, and then that is from the environment. Then from the economics, we found in the field that sometimes the farmer applies the rates of fertilizer is above of the recommendations we have. So if they apply based on the recommendations, so they will not waste the money and other resources. I think that that's Prof. Darusman.
Thank you very much, Bapak Dr. Hasmansa. I guess to listeners who have not understood yet can ask directly through private lines. Ladies and gentlemen, time is up and we almost done. But before we end up this webinar, let me summarize. Correct me if I make a mistake. It is clear that global temperature increase by time, and this increase of climate change affect all aspects of our human life, our human activities. Agriculture sector is playing important role in adaptation and mitigation strategies facing climate change. However, agriculture sector stand on adaptation scenario since Indonesian development goal is food security. Strategies of adaptation would promote food security and sustainability. And from Mr. Prof. Hans, I can summarize like this. Even though livestock genetics have been harvested by human beings, they have been transported and successfully adapted to various agroecologies and production systems across the world. Livestock farming is facing many challenges, either from natural stress or public pressures. Powerful genomic solution is expected to enhance the productivity and efficiency, to reduce methane production and water pollution from livestock sector. Ladies and gentlemen, that's all that I can summarize from this webinar. And thank you very much for Dr. Hasmansa, representative from Ministry of Agriculture, and also Prof. Hans for you guys' contribution during this webinar that I believe that is very important for us, as we stated earlier, that climate change affect all our human activities. And thanks again, ladies and gentlemen. Forgive me if I make many inconvenience during I chair this webinar. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Have you heard this story about a beautiful place? A place that makes you feel restful. In the midst of people who live in religious harmony. A place that makes you feel home, that makes you curious for more adventure. To start your journey, travel to the place where the story unfolds. Feel the sea breeze caress your face, and the sound of the waves breaking your consciousness. That you can see them through the beauty of woven fabrics. Or smell them through the scent of coffee that wafts in the air. If you've never heard it before, you may now find it intriguing. You may want to know every square inch of this place. From the beauty of its land to the depths of its seas. With an amazing biodiversity, heard this story about a land which has traditions so diverse. Meet these friendly people who will welcome you with warmth. After all, welcoming guests is their tradition. The light of Aceh, wonderful Indonesia.
Honorable guests, ladies and gentlemen, we will now witness the symbolic delivery of certificates by the Vice Rector for Academic Affairs of Universitas Syiah Kuala, Professor Dr. Engineer Agussabti, M.Si, IPU, to our keynote speakers, Professor Dr. Engineer Fadjry Djufry, M.Si, who is the head of Indonesian Agency for Agricultural Research and Development, and Professor Jianlin, who is the head of International Livestock Research Institute, Chinese Academy of Agricultural Science, China. Ladies and gentlemen, please welcome Vice Rector for Academic Affairs of Universitas Syiah Kuala.
Professor Dr. Fadjry Djufry, thank you for your time and the inspiring speech. Please accept this certificate of appreciation for your valuable contribution to our conference. Thank you. Professor Haryani, please accept our sincere appreciation for the outstanding keynote speech and your contribution to our conference. Thank
you. Ladies and gentlemen, the Committee of Icagri 2022 has provided door prizes for 6 lucky participants. This time, we will select 3 lucky participants that will receive a package from ARC at City Research Center and 3 t-shirts from Center for Sustainable Agricultural and Rural Development, Universitas Syiah Kuala. Therefore, the operator, please, the time is yours.
Very well, let us see the winners of the 6 prizes that have been prepared.
Yes, okay, we already see the wheel is spinning.
Yes.
I'm curious who will be the winner this time.
And so am I.
Okay, so we got the name already. Okay, congratulations to Fakhriza Alfinsa Abrar, okay? Now we will select, yes, 2 more participants that will receive a package from ARC. Okay, who will be the winner, the second winner this time? That will receive a... Okay, congratulations to Miss Eka Mutiasari. Now, one more participant that will receive a package from ARC. Oh, could it be me? What do you think?
Are our names in there?
Oh, congratulations to Putri Bella Safira. Now, Syam, we will select 3 T-shirts.
Winners?
Yes, from for 3 lucky participants. So, the operator, please.
Yeah, we still have 3 more prizes.
Yeah,
everybody.
3 more prizes that will get 3 T-shirts. Okay, so we got a name. Okay, congratulations to Kirana Putri Amalia.
Congratulations,
Okay,
madam.
yep, 2 more winners that will receive T-shirts from Center for Sustainable and Agricultural and Rural Development. Congratulations to Khairan, double Khairan.
Yeah, double Khairan. Mr.
Okay.
Khairan or Miss Khairan? Congratulations.
The last winner will be, can be someone in here.
Yes, it could always be.
Oh, you got a red one? Oh, okay. Congratulations to Professor Dr. Insinyur Ahmad Abu Bakar, M.Si PUS. Congratulations once again to all of the winners that get 3 packages from ARC and 3 T-shirts from Center for Rural Sustainable Agriculture and Rural Development Universitas Kuala. Please do contact us after the end of this session.
Very well. Distinguished guests, ladies and gentlemen, we are going to the first parallel session. For this session, the operator has provided a link, and there will be 14 breakout rooms for different speakers and moderators. Therefore, please follow the given instruction. This is break.
to the recommendation and do not apply fertilizer as needed, so that the plants are neglected and completed to grow together with the surrounding weeds. As we show in this picture, there are three types of cultivation, innovation level and cultivation. So refer to GEP and GSP. There's only 17% of farmer has started to practice good and correct good agriculture practice. Yeah, as we know, we have 40 respondents. 40 respondents as unit business in citronella agroindustry. Most of unit industry not good to handle raw material, citronella leaf for the processing of citronella oil. Yeah. If you measure the coefficient of cultivation innovation refer to application of good agricultural practices, the good citronella seed come from clones that are suitable for climate condition and soil type. Soil type in Gaiolus may be variation from mineral soil and clay soil. Practically, the age of seeding is also unknown for some time. The land and the availability of seed most cultivated customary for the from the family farm. So now let's move to significant innovation of the citronella agro industry in Gayulwes. I think the technology for the on farming system is very low, and activity on harvesting still bad value to suppose the
cultivation factor and percentage of disease incidents based on age and the nutmeg plant and cropping pattern. And disease incident, the best principle of where is 20 years, 25 years old plant had the lower incidence of disease, although statistically there was the significant difference. While monoculture crop pattern have a higher incidence of disease when compared to a polyculture. This picture is presented of disease incident based on weed control. Presented of disease incident based on weed control. In this case, the state of weed without control has more disease incidents, but statistically analysis is not significantly different from other control techniques. And this picture, environmental factor, and a graph of rainfall and rainy days that fluctuated for 15 years, but from 2010 to 2015. There was the decrease. There was decrease, and when white from the area, in fact, with the decrease, there was an increase. A graph or effect by disease, by dieback disease. And then the result,
component by customer in addition to attractive
the effectiveness Talaromysta phenophilus to control the dieback disease or nutmeg sickling, and is therefore a phase of the incubation period.
And next one, please. Here's our acknowledgement for the this research for the Ministry of Research and through Syiah Kuala University. And this one, please. That's all our my presentation for today. We hope you enjoy the discussion and probably if there's some issues we can discuss on coffee. When you do cupping test, actually, if you like coffee and then the way you do it, you slurp the coffee, so the coffee will go all the way in your mouth. So we'll be able to taste these 10 different attributes like body and sweet and acidity and aftertaste and all of that. Okay, thank you. I'll give it back to our moderator.
Thank you, Dr. Engineer Yusya Abu Bakar. Certainly, I enjoyed the presentation with my coffee. I hope participants have enjoyed and learned a lot from this presentation. Now, so we are in time. So I'd like to thank the speaker for being on time. Now, 5 to 10 minutes for discussion. So I'm expecting some queries, discussions, and questions from our audience or participants. Please feel free to raise your hand, and then you can unmute yourself and interact with our speaker. Anyone has any queries or comments? Okay, let me start so that audience will get warmed up. Okay, while we have a question coming up. So, sir, what could be the
and better leaf boil water with 4 hours of immersion can maintain the brightness of cut roast during the immersion time. Okay. Overall acceptance. Table 5, average organoleptic test on overall acceptance due to the interaction between treatment of various types of natural preservative solution and immersion time at day 6, 8, and 10 of observation. Based on the result of the organoleptic test on the structure at day 10 of observation, it shows that the table 5 show that at day 6 of observation, the panelists were more receptive to Sorry.
in the lithocarpus composition, yeah, amount, yeah, this one. This is just to show you how the proxies is applied to understand the past, vegetation, forest, or environmental dynamic in an area. So the next process is age dating. Yeah? In paleoecology, this is very important because we have to understand the sediment age from the surface until the bottom or the deeper sediment. Yes.
We have 2 more minutes.
Okay. I think I will. This is how to show you the radiocarbon dating. And the next process is non-pollen polynomorphs, which is the diverse group of quaternary microfossil. Yeah. And for the non-pollen polynomorphs, this variety of group cyanobacteria, algae, vascular plants, invertebrates, and fungi. But still a limited number of known taxa for the polynomorphs. And this is maybe might still develop in the future. This is the photomicroscopic of the non-pollen polynomorphs, like Botryococcus and spore of freshwater fungi. The next proxy is foraminifera or foraminifera test lining. One research that conducted in Aceh used foraminifera to understand the paleo tsunami. If you ever heard about the Gua Ek Lunti in the Lom in the Aceh Besar district, the researcher from Singapore take the sediment and then they extract foraminifera assemblage and also charcoal, and then they construct the ancient environment at that area and prove that tsunami happened in that area during 7,000 years ago in a periodical time, yeah, every
Have you heard this story about a beautiful place? A place that makes you feel restful. In the midst of people who live in religious harmony. A place that makes you feel home, that makes you curious for more adventure. Start your journey. Travel to the place where the story unfolds. Feel the sea breeze caress your face and the sound of the waves breaking your consciousness. That you can see them through the beauty of woven fabrics. Or smell them the scent of coffee that wafts in the air. If you have never heard it before, you may now find it intriguing. You may want to know every square inch of this place. From the beauty of its land to the depths of its seas. With an amazing biodiversity. Perhaps you've heard this story about a land which has traditions so diverse. Meet these friendly people who will welcome you with warmth. After all, welcoming guests is their tradition. The light of Aceh, wonderful Indonesia. Have you heard this story about a beautiful place? A place that makes you feel restful. In the midst of people who live in religious harmony. A place that makes you feel home, that makes you curious for more adventure. Start your journey. Travel to the place where the story unfolds. Feel the sea breeze caress your face and the sound of the waves breaking your consciousness. That you can see them through the beauty of woven fabrics. Or smell them through the scent of coffee that wafts in the air. If you have never heard it before, you may now find it intriguing. You may want to know every square inch of this place. From the beauty of its land to the depths of its seas. With an amazing biodiversity. Perhaps you've heard this story about a land which has traditions so diverse. Meet these friendly people who will welcome you with warmth. After all, welcoming guests is their tradition. The light of Aceh, wonderful Indonesia. Have you heard this story about a beautiful place? A place that makes you feel restful. In the midst of people who live in religious harmony. A place that makes you feel home, that makes you curious for more adventure. To start your journey, travel to the place where the story unfolds. Feel the sea breeze caress your face and the sound of the waves breaking your consciousness. That you can see them through the beauty of woven fabrics. Or smell them through the scent of coffee that wafts in the air. If you have never heard it before, you may now find it intriguing. You may want to know every square inch of this place. From the beauty of its land to the depths of its seas. With an amazing biodiversity. Perhaps you've heard this story about a land which has traditions so diverse. Meet these friendly people who will welcome you with warmth. After all, welcoming guests is their tradition. The light of Aceh, wonderful Indonesia.
Ladies and gentlemen, welcome back to Icagri 2022. Now we are continuing with the next speaker session, which will be moderated by Professor Dr. Ing Sri Haryani, S.T.P, M.Sc.
Professor Sri Haryani is a lecturer at the Faculty of Agriculture at the Universitas Kuala. She was born in Aceh Selatan, 15th of January 1972. Professor Sri Haryani finished her bachelor degree at Bogor Agricultural University and pursued her master degree at the University of Queensland, Australia. In 2011, she received a PhD from Bonn Universitas, Germany. Without further ado, let's welcome Professor Dr. Ing Sri Haryani, S.T.P. and S.Si.
Assalamualaikum warahmatullahi wabarakatuh. Welcome back to the afternoon session of the 4th Virtual International Conference on Agriculture and Bioindustry. I am Sri Haryani Anwar, moderator for the next keynote speeches for about 1 hour from now. Honorable guests, lecturers, students, moderators, and all participants from all around the world, we will have 2 keynote speakers, Professor Bhesh Bhandari from Australia and Professor Anna Keutgen from Austria. Let us welcome them for this conference. Hello, Professor Bhesh Bhandari. I hope you can clear my voice clearly. I cannot hear your voice yet.
Okay.
Oh, okay. Yes,
It's okay now?
Yeah, it's okay now.
Okay.
Yeah, okay. How are you today?
Very good.
Okay, good. Thank you. Hello, Professor Anna Keutgen. I hope you are doing well as well. Okay. We are all delighted to have...
Okay, hello.
Hello, Professor Keutgen. How are you today?
I'm fine, thank you, and I hope you too.
Okay, thank you. So, we are delighted to have you here today and ready to listen to your experience and knowledge. Just to remind you that each of you will have about 25 minutes for your presentation, and we will combine 20 minutes for question and answer as well as for discussions. Okay, without further ado, let's start our third speaker first. So please allow me to read briefly Professor Bhesh Bhandari curriculum vitae. Professor Bhesh Bhandari is a lecturer from the School of Agriculture and Food Sciences from the University of Queensland, Australia. He joined University of Queensland since 1993, and in fact, he was my lecturer in year 2001 until 2002. Professor Bhandari has research interest in food material science and engineering, encapsulation, food process engineering, 3D printing, nanostructure, and the food systems. Professor Bhandari graduated from Gujarat Agricultural University, India, for his bachelor degree in 1980. For his master degree in 1987 from Asian Institute of Technology, Thailand, and finally in the year 1992 he got the PhD from Syiah in France. Professor Bhandari has 85 H index, and he's actually author for more than 450 papers, 8 co-edited books, and 40 books chapters, yes. And Professor Bhandari publication are cited more than 30,000 times, which is a really great achievement in his career. Recently, Professor Bhandari has developed a patented technique to produce ethylene powder which can be used for fruit ripening and other plant physiological control. He also editor-in-chief of Future Food Journal, as well as editor for Journal of Food Engineering. Let us welcome Professor Bhandari for his presentation. Professor Bhandari, the time and screen is yours.
Thank you very much, Professor Sri Haryani. Can you hear me? Hello?
Yes, we can hear you.
Yeah, okay.
Yes.
Okay, thank you very much. And thanks to Icagri organizing committee for inviting me to present in this event. So as Professor Haryani mentioned that I had a patent on ethylene powder production. So I'm going to talk about what is ethylene powder, what I developed. Okay, so this is one of the sustainable technology. So why it is sustainable, what is involved with it, I'm going to describe about that and what is the application as well. So you can see here, this is a vacuum packed ethylene powder. So I'm going to give you some brief background, what does it mean and how it is produced and what are different applications. So firstly, the ethylene is a alkene compound. The formula is CS2, many of you know. It is an apolar, colorless, and flammable gas. It's recognized as a plant hormone, which is responsible for fruit ripening, the seed germination, and flowering of plants. Ethylene is naturally produced by fruits, especially the climacteric fruits are very sensitive to ethylene. They are ethylene dependent, ripening of those fruits. And the ethylene gas is produced by auto-stimulated process, and it is synthesized from methionine. So this is produced by the fruit itself, but you can apply from outside so to trigger the ripening of the fruit. So there are different fruit ripening agents used because ethylene is not really available in very convenient form. So normally many people or many farmers, they use calcium carbide as a ripening agent. It is based on the acetylene production from calcium carbide when it reacts with water. This acetylene is analog of ethylene, so it acts similar to ethylene for the ripening of the fruit. But calcium chloride is considered as hazardous and even carcinogenic because it has got traces of heavy metals, and then acetylene gas can cause different problems. So actually this is banned in many countries, but it has been illegally used because there is no proper alternative which is easy to use and cheaper as well. So there is another commercially available product which is called ethophone or ethrel. The commercial product is ethrel, produced by Bayer or marketed by Bayer. This is allowed to use in EU, Australia, and many countries. The main principle is that the chemical compound, active compound is ethylene, which penetrates into the fruit skin and decomposes to ethylene in the fruit skin. But still it is expensive and it is not easy to use, and it's again a chemical. It's not a natural compound as we are talking about ethylene. There is another artificial food ripening agent which is called ethylene glycol. This is also sometimes it is used, especially in cold climate conditions, but this is not as effective as the ethylene or calcium carbide or ethyl. So this is not very much used. Smoke, we know that in the countryside, in the farmers, sometimes they may use smoke, which is not very effective because it has got still acetylene or ethylene as a part of the smoke compound, but the concentration is very low, and it is it gives some effect, but it's not very effective as ethylene. So now ethylene is the most effective one if you want to use it. But one of the problem with ethylene is it has got very low solubility in water. It is delivered in cylinders or canisters in compressed form. It is flammable, very dangerous gas. It can catch fire very easily. It can spark and catch fire. Very, very dangerous gas. And if it is required in a small amount, it's not convenient to use ethylene in a compressed form. And that's why it is unsafe gas, actually. So what is the solution? The solution is if you can convert the ethylene gas into the powder form by entrapping into the solid matrix, maybe that could be a good solution. It's similar to the method of converting liquid to powder form by encapsulation. So there are different entrapment processes we can see, gas absorbent or other compounds, nano microporous polymers, carbon nanotubes. There are different possibility of entrapment of the gases, and people have done some work on entrapment of gases, not necessarily with ethylene, but with other gases. But they are very ineffective because the concentration of the gas is very low. You need very high pressure for the absorption of the gases in those solid matrices, and very high temperature required for release, because once you encapsulate it has to be released easily, but it's not that feasible because you need to apply very high temperature. And they are not really intended to use in the food product. So, and because most of the compounds, they are not non-biocompatible. So you cannot use in pharmaceutical, medicine, cosmetic, or agricultural food. It's not acceptable. So I used a biocompatible compound, which is called cyclodextrin. It is cyclodextrin compound. It's almost like a starch derivative, I would say. So you have got glucose. It's a glucose ring molecule. You know, there are a number of glucose molecules. There are 6 glucose molecules here, 7 glucose molecules. It's called cyclodextrin. Depending on how many glucose molecules are combined together, you know, or they are like it's a crown of glucose molecule. There are 3 different types of cyclodextrin. One is beta cyclodextrin, alpha cyclodextrin. Second one is beta cyclodextrin, gamma cyclodextrin. Depending on how many glucose molecules are joined together to form a ring or crown type of structure. And 6 molecule, glucose molecule, when they join them together to form a crown structure, that is called alpha cyclodextrin. This has got cavity. In all those cyclodextrin, they have got cavity, which is hydrophobic. Hydrophobic means they can entrap hydrophobic molecules, such as gases. Many gases are hydrophobic. So the interaction between the hydrophobic molecule and also the the gas molecule and the cavity could be hydrophobic interaction. It is a non-covalent, could be by van der Waals forces or hydrogen bond or electrostatic forces. Different type of bond occurs between the cavity of that cyclodextrin molecule and the gas. Okay, so that means it's a molecular encapsulation. So the molecule of the gas go to the another molecule of the cyclodextrin, just fits on the cavity here. So it forms a complex. That's called complex, gas complex with cyclodextrin. So for example, you have got ethylene, which can complex with alpha cyclodextrin because the cavity size is small enough, you know, so that that fits well with or big enough or small enough. It's similar to the size of the ethylene molecule. So it forms a complex with the ethylene molecule. So the ethylene molecule just fits inside the cavity of cyclodextrin. So that forms a complex. So now how you make the complex is make a saturated solution of alpha cyclodextrin and inject ethylene gas under pressure. You form a complex. When it forms a complex with the alpha cyclodextrin molecule, when the ethylene gas or any gas actually complexes with alpha cyclodextrin molecule, that becomes crystallizes because the solubility of the complex molecule is very, very low. So it crystallizes out. When it crystallizes out, you just separate the crystal by filtration, and dry the crystal, and you get a crystalline powder. It's a very simple process actually. So you make a saturated solution, inject the ethylene gas under pressure, it complexes out, and you get a ethylene powder. Very simple process of this solution by using this solution of alpha cyclohexane. So, but the encapsulation time is very long, up to 120 hours, and depending on the pressure you apply, you get the yield or the crystal recovery up to, let us say, 45%. If you pressurize to 15 bar, you can get 45% yield. But you have to wait for more than 120 hours. So this process is very time consuming, as well as yield is less than 50%. So you get less than 50% powder. So this is not a really good method. So, but you can see that this sort of powder still contains 1 gram of powder contains 26 milliliter of pure ethylene gas. So if you take 1 gram of powder, you have about 26 milliliter of pure ethylene gas. Remember that ethylene gas required for ripening of fruit is very, very low, 100 ppm, even less than 100 ppm. So you don't need a lot of powder. So in this powder, it's equivalent to 40 times compaction of the gas in the powder form. So as I told you that this solution method is very time consuming and the yield is very low. So what we did is, I developed a method of complexing ethylene with the solid cyclohexane directly, no need of making solution. So, but one thing is, what you have to do is, you have to make amorphous solid powder. So if you make an amorphous powder, you can complex directly ethylene into the that means that you are complexing directly, there is no solution, there is no crystallization, so you can get 100% yield. So you get whatever powder you used, you can recover all the powder. That means that there is 100% yield. And the time required for complexion is very low as well. It's not very, very high. Up to 48 hours, you can complex the powder, complete complexation, which is almost like 1 molecule of cyclohexane complexed with 1 molecule of ethylene. So the mole ratio is 1:1 almost, 0.98 is close to 1. So that means within 48 hours, you get all the molecules of cyclohexane complexed with gas. So that means that you can get full gas encapsulation and the yield is 100%. So this is the method which we patented. It's a simple method, easy to use, easy to do it, easy to apply. So that's what the powder we made, ethylene powder, okay, which is vacuum packed. You can imagine that you are vacuum packing the gas powder. So still gas is not released, so it's under vacuum. So I have got a powder like this for last maybe 5-6 years. So the vacuum has not been broken. So that means that the gas is intact in this one. And just to keep in mind that the gas concentration in the powder is 3.5% by weight. So 3.5 gram of powder in 100 gram of powder. Okay, sorry, 3.5 gram of gas, ethylene gas in 100 gram of powder. So 3.5 gram of gas is a lot of gas actually in terms of the weight, because gas is, if you think about volume, 3.5 can convert to a lot of gas. So now once you encapsulate, how do you release? That's very important. Just controlling the humidity, you can release the ethylene. For example, here, if it is the humidity is less than 52% or 50%, there is no release of the gas. As you increase the humidity of the environment, there is a fast release of the gas. So if you want to have fast release, you apply very high humidity. If you don't want to release, the humidity has to be maintained below 50%. Okay? So same thing, these are the models. Same thing you can do release by temperature. Below 45 degrees Celsius, there is no release. If you heat the powder above 65 or 85 degrees Celsius, there is a very fast release of the gas. So either you use humidity method or temperature method. Temperature method is not really good one because very difficult to apply temperature. But the humidity method is very easy because normally if you want to ripen the fruit, it's already humidity is very high. So probably you don't need to control any humidity, because in the room, humidity is very high. Just put the powder, it will release the gas automatically, because the humidity will be more than 75% in a room where you have got the fruits. So if you really want to release the gas at very low humidity, you can use the deliquescence property of different salts, okay? Because some salts dissolve at very low humidity. If in case you want to release at very low humidity, as I told you that ethylene gas cannot be released for less than 50% humidity, but it is possible to release at low humidity if you can mix that ethylene powder with the deliquescent salt, like calcium chloride or magnesium chloride. They melt or they dissolve at very, very low humidity, 28%, 33% humidity, they become liquid. For example, you have got calcium chloride, magnesium chloride. If you expose to that humidity condition, 28% very low humidity actually, 33% very low humidity, they become solution actually, because they absorb the water and they dissolve actually. They form a very concentrated solution. These concentrated solutions are considered as ionic solution. Okay, they have got restructured water, they have got a strong solvation property, they have got 9 times dissolution power than the pure water. So that means if you mix ethylene powder with the, for example, calcium chloride, mix them together, expose to critical deliquescence humidity, which is 28%. If the humidity is more than 28%, that calcium chloride will dissolve, and then you have got this ethylene powder inside. You can see there is inside, and then all this liquid of calcium chloride, and you can see gas is releasing from here. You can see the bubble of the gas releasing from the ethylene powder. So if you want to release at very, very low humidity, it is possible to use the deliquescent salt. Sorry. Now I am talking about about the application of the ethylene powder. Now ethylene powder can replace the compressed ethylene cylinder, and powder can be used in large or small volume, because you can use milligram of powder or kilogram of powder. That means you can ripen large quantity, tons of fruits or small volume of fruit. And in-transit ripening is possible. So I'll just go through that one later on. For example, if you use ethylene powder, 20 to 30 ppm, you can see the mango ripening here. In 7 days, you have got very uniform ripening of the mango just by using the powder. And you don't need to spray the powder, just put on the side of the mango, then it doesn't have to touch, like you have got its petri dish, it doesn't have to touch. Even though you touch, that's food grade material, cyclodextrin is food actually. So even though you touch doesn't matter, but you don't have to touch, just put in the sachet or just open, it will release the gas and ripen the fruit. Same thing, we did some comparison between the calcium chloride and Ripistop. We call that ethylene powder what we produced. You can see that Ripistop is as effective as calcium chloride, so it can easily replace calcium chloride. Okay, so it's as good as calcium chloride. Okay, so it is good replacement for calcium chloride. So we did some trial in the ripening room as well with banana. You can see about using 100 ppm, banana ripens within the day, So that's the temperature, 17 days, I would say within 3 days, you have got uniformly ripened banana in the ripening room. And then in transit ripening, normally you transport fruit from one place to another place, and you need control room storage for ripening, because you transport, let us say, 1 day, 2 days, even more than 2 days. And you have to store in the ripening room, inject the ripening gas, treat it, and then release in the market. Now, using the gas, it's not necessary to use the control room, because you can just put the gas powder in the truck inside, so it will ripen on the way. That means you trigger the ripening on the way, and then you don't need that storage facility. It can go directly to the market, to the distribution. So it is possible to do in-transit ripening of fruits that way. So you don't need that control room storage for ripening. So it saves a lot of cost. Another example here is with mung bean sprout, we did just using 5 ppm of ethylene in water, because you soak mung bean in water. So you put a small amount of powder into the liter of water, 500 milligram, which is very less than half a gram of powder, 1 liter of water. you see that the germination is so different here. This untreated one, treated one. You can see this, it has got thick hypocotyl, exaggerated apical hook, and short roots. You know, you can see very healthy plants. So that's another application of ethylene. And another group within our school did some work on the Bermuda grass, which is very very drought tolerant grass, lawn grass. So they tried with ethylene powder with along with other hormones, you know, which are used to germinate seeds of this Bermuda grass. And ethylene power, using the ethylene powder, they found out that the germination was as effective as by using other hormones. So we also tried with the germination of paddy seeds using 5 ppm ethylene. So it was possible to use the ethylene gas to have very fast germination as well as very high percentage of germination. You can see using the classical gibberellic acid, which is another hormone used for seed germination, triggered seed germination. So just comparing with that one, that was not effective at all, that classical gibberellic acid, but ethylene was very effective. And even it was allowing germination of the defective seed as well. So there were very defective seed left to germinate. So it was possible to germinate more seeds by using ethylene gas. Okay, so that means that what ethylene gas we use by using our ethylene powder in the water. So just put in the water ethylene powder, that will release the ethylene gas. So this is not the experiment with the ethylene, as I told you. This is the experiment with the using the ethylene powder, because ethylene, effect of the ethylene on ripening, germination is all known. You don't have to really do that experiment. But the thing is, I want to show that ethylene powder is very easy to use. You have got a powder, you put a small amount, and then does the work, you know, by releasing ethylene gas. So finally, I would say that ethylene gas encapsulated in a food material, actually cyclorexene is a food material. It's a great opportunity for the future in fruit ripening and seed with germinations. Okay, so it's a very sustainable solution to replace chemical-based ripening agent. So this is the end of my presentation. I would like to acknowledge my PhD student who was able to produce ethylene powder. He is the co-inventor of the ethylene powder, what we patented, and some other students like Hang Tran, Xin Chao, they were also doing experiment with different seed germination work, and Dr. Tran Tin Van also did with the turf grass. So I would like to acknowledge them. Thank you very much. Any question? I mean, that will be done later on anyway. So thank you everyone.
Thank you so much, Professor Bhandari, for very interesting presentations. It brings a lot of us. So we will do the discussion and question and answer with you after Professor Keutgen presentation. So please remain with us here in Zoom. Ladies and gentlemen, let's proceed to fourth or the last keynote speaker. So I'll welcome Professor Anna Keutgen. Professor Anna, I hope I spell your family name correctly. Before
Yes, you do.
Thank you. Before your presentation, please allow me to read your curriculum vitae briefly. Right, Professor Anna Keutgen is a professor, university professor from 2014 from University of Natural Resources and Life Sciences in Vienna, Austria. Professor Keutgen has research interest in management in added value chains, also in physiology of yield and quality, as well as for horticultural production and resilience, control environment, horticulture and storage, and stress management in plants. So Professor Keutgen actually has become a research scientist during 1996 and 1998 in University of Bonn, the same university when I spent my PhD about 11 years ago. So apparently I have indirect connection or direct connection with our two speakers today. It is very interesting. And Professor Keutgen previously, during 2002-2008, has become associate professor at University of Göttingen in Germany, and also becoming marketing division in food product design. So Professor Keutgen will share her knowledge and experience and presentation today entitled Climate Change, Challenges and Limitation in Agriculture. So Professor Keutgen, I welcome you, and time and screen is yours.
So,
unmute your voice.
Can you hear me? And can you see my presentation?
Yes, we can see as well in the screen your presentation.
Okay, yeah. Professor Sri Haryani, thank you very much for the introduction and giving me the opportunity to present some findings on knowledge about the impact of global climate change on agriculture. In the one hand, I would like to go into the challenges, and the other hand into the opportunities. My speech will be more general, just to make just a great vision about what we have to expect and what we have to do in the next time. You know, it is actually on everyone's lips that the climate is changing. But actually, what does it mean? You know, after the United Nations definition, it is just related to long-term shifts in the temperatures or weather patterns, a period of prolonged cooling, so-called ice ages, are followed by warming, and even much greater than that can be observed today. Of course, you may imagine that the climatic change is not new. The world is not a rigid system, and changes occur just permanently. So it means that the climate is changing since the emergence of the Earth. So the question is, why now we are afraid of it? Of course, you may see it here that we have natural causes of changes from the beginning, so as a solar activity, variations in the solar cycle, arrangement of the continents, thickness of snow and ice caps, we may say also meteorite impact, volcanic activity, and also the concentration of aerosols in the atmosphere. But the problem is that since the 1800s, we have a new factor which is quite strongly impacting the climate. It is the humankind. So it means human activities when we use the oil, gas, petroleum, and so on for just driving the cars, fly the plane, and also heating and cooking. They are impacting the climate very strong. So it is also becoming increasingly clear that the climate change will accelerate in the coming decades, and it is no longer to be stopped. Because the consequences in all areas of life are so severe, several countermeasures to mitigate the consequences of climate change are, of course, needed. You may see here this result of our activity is just the higher emission of such greenhouses as a methane or also carbon dioxide. So, which prevent heat escaping from the atmosphere, terribly driving global warming. And of course, we need, to a certain extent, the global warming, otherwise it would be too cold for us to live. However, these changes are too fast and too serious. So it means that the nature cannot adapt fast enough to these changes. Because, you know, nature is actually has such solution, such problems, but the self-regulatory power is just exhausted. So it means we have also somehow to help to counteract. Because it is so severe, there is an intergovernmental panel on climate change called also IPCC, and it developed different models how the climate will develop. Depends, of course, on the different scenarios of human activities, also due to the changes of fluctuation of concentration of greenhouse gases, and also the reaction of the environment. So there are 4 such models, but I want to present only 2 of them. Most extreme, so it means RCP as a representative concentration pathway, 8.5, when we do nothing and the business as usual will just going on. It is just a path to the climate catastrophe. So, especially that it will occur that the greenhouse gases emission continues and the population of human will increase considerably. What we may expect that at the year 2100, the averaging temperature will be 4 centigrade above the pre-industrial levels, but it will occur also unequally and may reach even 6 to 10 centigrade. As the result, very significant risks are predicted for most of mankind. Alternatively, the governments around the world may make a choice for the RCP 2.6, the ambitions or strident climate policy. It means in this model, the greenhouse gases emission would peak before 2030 and thereafter fall continuously. In this case, the climate change can be somehow stopped and the targeted temperature of 1.6 centigrade can be reached, so compared to the pre-industrial level. And of course, on this way, the consequences of the damages of climate change can be reduced. But what we have to do, we have to act immediate to reduce the greenhouse gases emissions and also use ambitious climate policies. And what is compulsory, there are negative carbon dioxide emissions needed, for example, by the binding capacity of the trees. And on this way, a targeted temperature increase of at the maximum 1.5 to 2 centigrade is still possible or achievable, as it is mentioned in Paris Climate Agreement. The changes in temperature at the end of the 21st century are predicted to be about 0.3 to 1.7 centigrade under RCP 2.6, so this ambition plan, and 2.6 to even 4.8 centigrade under RCP 8.5, business as usual. Especially, as you may see here, the Arctic regions will suffer from the highest temperature increase, much above the global mean. In several areas, it is to expect that more hot days and especially also heat waves, as well as fewer cold temperatures extremes will occur. Occasional cold winter extremes will continue too. If you look on the precipitation in both models, the changes will not be uniform. In the RCP 2.6, the changes are generally moderate, where the lower precipitation will occur in the mid latitude and also subtropical dry areas, as well as what is important for the Europe in the Mediterranean area, in the south of Europe. In the RCP 8.5, this trend will be significant stronger and will also cover the southern part of the Europe quite strongly. However, the equatorial Pacific, as it is shown here, the poles and also wet regions, tropical areas in Africa, for example, they will be characterized by significantly higher annual mean precipitation. And also this precipitation will be more frequent and more intense. So, extreme weather conditions. Focuses on Europe and projects, the changes in the annual presented here on the left, and also in the summer precipitation in the period of 2071 to 2100 compared to the baseline period of 1971 to 2000. For the forcing scenario, RCP 8.5 is obvious that especially you may see here Mediterranean area, but also Turkey will suffer the drought. So it means lack of rain, especially during the summer. The problem is this area, we may say it is a corn or a chamber or vegetables chamber for the whole Europe and not only. So it means this area will be just undergo desertification, a big problem for the humankind. A reduced precipitation will also result in the lack of drinking water. So already more than 80% of the available precipitation is used by irrigated agriculture, different industries, and municipalities. This situation may intensify, especially in temperate regions, due to a modified jet stream, as you may see it here, as a consequence of the global climate change. The wet and storm areas marked here blue, and the hot and dry zones marked here red, intensify, expand, and get stuck over one area for longer, resulting either for a longer drought period or of heavy rain that cannot be taken up by desiccated soil. How drought will increase by the end of this century may be estimated by the Palmer Drought Index or Palmer Drought Severity Index. As a matter of fact, serious scientists consider that the most important challenge of the global climate change is not the temperature increase, but the water crisis. But since the 1800s, human activities are considered, as I mentioned before, the main driver of climate change. So you may see primary due to the burning of coal, oil, gas, and also especially the land use change. Land use change is any way in which humans modify the natural landscape. And most of these changes are actually permanent destruction of the natural ecosystem, such as urban just development, deforestation, slash and burn agriculture. Other changes which may counteract these changes can be cropland abandonment and also forest restoration. So there is also the hope. But as you may see, the agriculture and climate change may be characterized by quite difficult relationship and can be manifold. Generally, we may put it into three groups. So agriculture can be a contributor for climate change. Impacts of climate change is quite severe on agriculture, and also agriculture can be a part of the solution of climate change. I will go into the first aspect, the agriculture as a contributor to climate change. You may see that it is mentioned that agriculture is cause of 30% of total global anthropogenic emissions of greenhouse gases. So in the form of particulate matter or greenhouse gases from land use, like the emissions of methane from the, for example, rice production or livestock, and also the nitrogen oxide in form of fertilizer or manures. Maybe more interesting is just a summary of energy requirements in agriculture. So as you may see it here in the case of protected crops and cereals, this use is quite very intensive and very high. So probably we have to rethink how to grow our crops. And you may see that the petroleum products make up more than 50% of such costs or use, followed by electricity by 36% and gas by 12%. Obviously, the impacts of climate change on agriculture are manifold. In addition to challenges in order to reduce greenhouse gases emissions, agriculture and also rural areas as a whole also have to face up to the impact of the ongoing climate change. The vulnerability of the agriculture sector as a whole will depend on the nature and intensity of climate change, how itself, and how strongly the system within the agriculture sector can be affected, because we don't do anything to mitigate or avoid such influences. And of course, if the agricultural system can adapt to these changes. What we may expect when you see, of course, we have rapidly increasing CO2 concentration, partially dispositive to the plants, because it can be used as a fertilizer, rising average temperatures, we have increase of warmer, drier summers, increase of warmer, wetter winters with less snow. The climate will be more variable, and especially disaster or extreme will occur in different form, heat waves, floods, storms, and so on. Or debris flows, what is a big problem in Austria. Rising tropospheric ozone concentrations, sea level will rise, we may expect yield failures, soil erosion, and also glaciers meltdown. Because Austria is my home country, I want also to show you that the global changes are just covering also the changes for Austria, and this is one of the countries which will be impaired quite in a certain extent. So it means the temperature are rising already now. We have about the mean or the average rise of 1.6 centigrade. The summers are hotter and drier, and we have twice as many days above 30 centigrade as before. This is a problem also of water and cultivation and also heat stress. We have less cold on average winters, and they are also less snowy, and the snow cover is decreasing. Because Austria is a mountain country, we have alpine regions. It is very also important to know which changes are also occurring there, like temperature rise. We have also partial increased intensity and frequency of precipitation. We may expect more hail, but also more droughts, reduced soil water content, flooding, debris flow, but also pest invasions. And what is also the problem, the permafrost line will rise and increased danger of landslides just increase. And we have glaciers retreat. Maybe you may say, no, yeah, that is not a big problem, but it is so because about in the last 100 years, about 50% of glaciers retreated due to the temperature increases. And this is to expect that it will increase significantly in the next time. What is the consequence? We have loss of natural water reservoirs. The attractiveness of the mountain regions is reduced, and also it will negatively influence the winter tourism. But what will be with the agriculture? We will get as the consequence the increased drought and climate variability. We may also expect several yield and quality losses and yield security. And as a consequence also of glacier melts, as a barrier from the insects pests will increase, especially heat-loving species that are spreading at the moment to the north. But not only insect pests, but also some diseases like phytoplasma. Because in Austria, agriculture is quite close combined with the forestry, and they are impacting each other. Also, the same problems are also occurring in the forestry, and also additionally, the structure in forest species will also change. The common native species, the spruce, is the big loser because of the occurring drought. Furthermore, to all of the species, the drought stress and increased pest infestation will increase, and the mountain forest will lose its protective function to the mountains. So what we have also to deal with forest fires in summer, as it is already present in the Mediterranean areas. For the further changes, you may see that warmer and less amount of cold days and nights at the same time with warmer and more hot days and nights will result on the one hand in higher yield in cold regions, but in the warm areas with lower yield and higher pressure of pests. So we have changes and challenges, or opportunities. We have also higher occurrence of hot days and heat waves, and then we may also expect yield loss and temperature stress, included danger of fire. We have also higher probability of heavy rainfall. This is also combined with yield and quality loss, but also soil erosion. And difficulties in the cultivation. Increase of areas of suffering drought combined with soil degradation and erosion can be expected. And also increase of tornadoes in tropical areas, but also in Austria, which may cause devastation of plants. On a global scale, the increase of water level in seas and oceans can be also added. For the mid-Europe, the specific impact of climate change in agriculture will cause that many already occurring risks become more widespread and frequent. First, the risk of late frost will increase. This will occur more frequently and more intensively. On average, every 10th plant is already flowering 5 days earlier than 10 years ago due to the temperature shift and earlier vegetation start. Because the plants are sprouting earlier and earlier, late frosts will become more severe, especially fruit trees are susceptible to frost even when the blossoms are still closed. Many frost-sensitive vegetables can be planted out only after the frost has passed. Late frosts can significantly reduce or even completely wipe out flower or fruit set or even entire plants. Rusting, also browning or star-shaped bursting or watery damage lead to yield reduction and quality losses. The rising temperatures, extreme heat phases, and high levels of radiation as a consequence of climate change can lead to major damage by burning of leaves or fruit, as you may see it here on the picture. Damaged leaves can no longer assimilate CO2 and provide sun protection to the fruits, which in turn increases the risk of sunburn. Sunburn on leaves and fruits leads to failures. Plants fall into heat rigidity. For example, tomatoes do not ripen over the temperature of 32 centigrade or suffer just held dead. Climate control in the greenhouse becomes increasingly difficult. Shading becomes necessity for the greenhouse and also for the field. Otherwise, we will get problems with sunburn. Prolonged drought during the summer months also increase the need for irrigation. Actually now, growth and development, or especially quality development, are not possible without an adequate water supply, or can grow and develop only to a limited extent. Even the meadows has to be irrigated. Rising temperatures are associated with higher water consumption. One positive effect, as I mentioned before, is CO2 increase because it is a fertilizer and additionally extended cultivation period. The mild temperatures that set in earlier in the year and the longer, mostly mild autumns, extend the gardening year by several weeks, if sufficient water is available. Lettuces and sowings can be started earlier in the year. Harvesting of typical autumn crops can be postponed from early October to November or even December. So actually for the time in which in the previous time we did not cultivate any vegetables. In the late summer, leafy, cabbage and root vegetables such as spinach, radish, sugar beet, Chinese cabbage and so on can be still planted until the end of the year. In many places, these vegetables can already be harvested in December, if necessary, protected by foil tunnels or by fleece without any additional energy. A longer growing season may result in more cultivated crops per year and thus higher productivity per hectare. Soil freezing tends to occur later, if at all. For this reason, digging or plowing should be also postponed. If it is done too early, many nutrients are lost from the soil. Because of lack of soil freezing, the sowing of mainly overwintering green manure is thus gaining more importance. Due to the longer, higher temperatures in winter, which should be also be watched out for seeding in the winter months. Some, for example, ragwort, used to die off in autumn, but now they flower and continue to seed. Consequently, the wheat pressure may generally increase. New pests may also appear as a global warming generally seems to favor pests, and hopefully we hope that the beneficial insects too. I want just to show you some striking figures which may underline this statement. You may see here the brassicas were planted and actually directly after almost died, and the planting was stopped because it doesn't make any sense to do it. Less than 1 month later, the same plot is just flooded, and you may see also such plants have to deal with a very serious stress situations. As a consequence of the warm, wet autumn, we may see also the delay in potato harvest, and we have generally also the problems with the storage of potato tubers because they are too warm for the proper cooling for storage time. We have also delay in autumn field work, and then we have problems with the organizing of our work. What we may also mention is the increased disease in autumn by cereals, and we may also expect that the clubroot in oilseed, Plasmidophora brassica, will occur more frequent. In the case of the potatoes, furthermore, warm winter will increase the risk of wet rots, early sprouting, and also secondary growth in the stores because the metabolism is working too effective and is too high. The secondary growth also associated with lack of irrigation may occur. In the case of the cabbage, we may expect that, but also cabbage and leek, the thrips can be trapped inside the cabbage head and are continuing to reproduce during the storage. Wet and warm winters may also result in conditions such that the land is too wet to work with. So as you may see it here, we cannot go with the heavy machines for the field preparation. We have to wait until the soil will be dry or drier. What we may summarize as an impact of climate change on agriculture, in the case of corn, we will get problems because of high night temperatures, high temperatures during pollination, and also water stress. So it means that the corn will be not set. Soybean can somehow deal with water stress and high temperatures, but the quality is not good. Wheat and small grains, here extreme events or frost during flowering, water stress may cause several yield losses. You may see every 1 centidegree increase in temperature caused the reduction in the yield by 4 to 5 million tons. When we shift the cultivation time, so it means we plant in time, the losses are only, we may say, 1 to 2 million tons, which is also a lot. In the case of rice, temperature extremes during pollination are critical, and also water management, especially drought, is very dangerous to them. Cotton, high temperatures during ball fill are critical. For the pasture and rangeland, water stress is a problem. For fruit trees, chilling requirements are not met, so it means the setting of the flowers will not occur on the proper way, and high temperatures during fruit development are also critical to see. And then in the case of specialty crops, water stress and high temperatures will cause yield loss and quality loss. Sensitivities to extreme weather as influenced by crop type may be also summarized as follow. You may see.
Excuse me, Professor
Keutgen. Okay, that you may see. Yeah.
Yeah, it's
that the different crops will result in the just different vulnerable processes, but at the end, the yield loss and the quality will drop, especially due to the high temperatures in summer and also high temperatures in winter, and the development and cultivation of such crops will be just limited. You may see here just the development and prediction. How does it look in the case of the wheat? At the moment, it is somehow stable, but if the trend will go on, we have to expect a serious reduction in the yield. As I mentioned before, the climate change, it is also a big phytopathological view, especially different bugs are the winners of climate change, but also aphids and spite mites. We may say that in this case we have more population per one vegetation or period or year. One also a big problem is phytoplasma, which was 10 years ago not present in Austria. Now the whole plantages, for example, of wine, but also tomatoes, potatoes, but also perennial plants like herbs are dying because we have also the development of the vector. It is the cicads like Hyalestes obsoletus. These are these two bugs which are most serious to the plants in the Austria. We have brown marmorated stink bug, but also southern green shield bug, which are causing damages on the fruits, but also they are skeletonizing the whole plants. We have also additional pests, new pests like diamond back moth. You may see, especially they are developed by very high temperature compared to the common pests and diseases here in the Austria. Also, fungal infections may increase, especially when the weather will be warmer and hotter, and then they can also develop to a certain extent the thermotolerance. As you may see, the temperate zone, just for example, is most impacted by the climate change, and we have to expect with different problems, not only combined to the direct agriculture, but also to the socio-economic efforts like productivity, price development, higher risk of hunger, lack of food security, and also due to the desertification, migration of the people. And the last part, very short, the agriculture can be also a part of the solution, because through the cultivation of the biomass, we may just proceed the sequestration of carbon, and we have to include better crop rotation with introduction of green manure. Agroforestry is quite interesting solution, and conservation tillage, just to reduce the CO2 emissions. Here it is a possibility to reduce up to 15%. Small but still important is the application of organic farming, because we have enhanced carbon storage in the soil. And of course, we may use new varieties, which we may deal with the drought, with heat, but also on the other hand, also with flooding. We have to think about new farm management practices, even up to vertical farming, but they are also still energy consuming. We have rethink the change in land use, and also we have to incorporate integrated watershed management. And as a conclusion, you see, we have just to stop or to mitigate the global climate change influences or the negative changes, we have to adapt and optimize the cultivation planning, irrigation practices, and also nutrient supply. We have to look on the crop protection management to reduce the introduction of chemicals, and we have to provide conscious risk management. And we should also not forget about the economic orientation to changing legal framework conditions, and also change competitive situation. So thank you very much for your attention, and please do not hesitate to give me any questions. Thank you very much.
Thank you, Professor Anna Keutgen, for very interesting presentation, as well as for your estimation for our future here on Earth, about how the climate change will change our life from long time ago until in the future. Let's continue this session with question and answer as well as discussion. I hope Professor Bhandari is still here with us. We already have 3 questions from the audience from the Zoom meeting, via Zoom meeting. So I just read the question. The first one will address for Professor Bhandari. The first question from Zaidia. The question is, in mechanism point of view, how long encapsulated ethylene resists in room temperature? Is there any specific temperature in using encapsulated ethylene? That's the first question for Professor Bhesh. And
okay.
Yes.
Shall I answer that one first? Or
yes, sure. You can answer that question first.
so that I don't forget that one. Yeah. There is no, I mean, you can do the encapsulation at room temperature. You don't have to really do high or low temperature. You can just do at room temperature. About the, what was the other question? The
question, the second question also for Professor Bhandari. Dear Professor Bhesh, I'm Dian Hasni, and so happy to listen your speech again. We can say that the ethylene application could be used when we transport unripe banana from Indonesia to Queensland. So we can slowly ripening banana during transportation time by releasing gas in low humidity. So how about the use of ethylene powder to prolong the shelf life of vegetables and fruit in refrigerator?
Yeah, thank you. That's an interesting question, the first one. Yes, the purpose of in-transit ripening is ripening the fruit on the route. So if you are, if the banana is being transported from Indonesia to Australia, yes, you can use the ethylene powder and ripen on the route, in transit to Australia. Yeah, that's possible. In terms of the shelf life, actually, ethylene treatment reduces the shelf life because it is going to ripen in terms of shelf life. So it is not going to affect positively the shelf life because, ethylene is that triggers ripening, that triggers germination, so that's, towards the end of the life cycle. So it is not going to improve the shelf life.
Okay, thank you, Professor Bhandari, for the explanation for the first and the second question. So let us go to another question addressed to Professor Keutgen. So this is, I just read the questions, is actually from Raihan Randy Pratama. He is a student from our faculty. So based on your long-term research regarding the impact of climate change on agricultural product, do you have idea in which way the global warming affect both the quantity and the quality of food crops? And do you have data which food crop is the most affected one?
Thank you very much for the question. A good question. Actually, what we have to expect that generally, in the case of all of the plants, we have to reconsider the quality issues. So now there are many discussions to lower the quality requirements for fruits and vegetables, because we can, at such circumstances, we are not able to produce such high quality in the field. When we do it as an indoor farming, it is of course possible. Which plants? Actually, as I mentioned, you could see wheat, potato, but also especially all plants which are which deserves a lot of water. So it means vegetables too. Of course, you have such differences between the also cabbage and also, for example, leafy vegetables. But nevertheless, it is not only water, also the temperature. So actually, that negative impact will go through the all of these species. However, what we are also working now, we are cultivating, for example, vegetables in winter time, what was not present or not usual before, and then we avoid somehow the high temperature and also water stress, because in the winter we have still more water. So we have somehow also to reconsider the common practices and find the new ways, because all of the plants will be affected.
For your answer for that certain question. So now there is one participant via Zoom, Professor Sabah Malau. So he wants to ask directly the question. Please mention your question and to whom the question is addressed.
Thank you very much, Moderator. My question is for all of us, especially for the keynote speaker. Guten Tag, Prof. Anne. My doctor father, Professor Robalen at Keutgen University, had ever told us, the PhD student, that genetic has a limited ability to modify. So if the temperature is going on to increase continuously, so the genetic cannot be modified so fast, so good to adopt this climate change. What do you think about that, Professor Anne and also Professor Bhesh? I don't know whether you are both a genetician or plant breeding scientist, but this is good also for us, for the people, the young people, to understand whether this is the best way to strategy. Whether the best strategy is to punishment the government that produce CO2 more and more to the atmosphere. So please let us know your opinion, your scientific opinion about that. I'm not sure that the genetician, that plant breeder, that agronomists and etc. can overcome this problem if the temperature is continuous climbing, as presented in this morning by the other scientists. Thank you. Dankeschön, Prof. Anna and also Prof. Bhesh. Guten Tag.
Thank you, Professor Malau. So I think, yeah, Professor Keutgen or Professor Bhandari can respond to these questions, please.
Okay, should I start? Theoretically, you are right, but in the practice, it is so that these changes are occurring too fast compared to the development of new varieties. So you may see actually we have no really resistant plant varieties to the drought stress, or what is more difficult, to extreme weather conditions, like for the drought and also for the water stress, because these are different mechanisms. So of course, your question is also directing probably the genetically modified organism, but this is a big also questions of the use, application, and also law. In Austria, it is not allowed to use GMOs. Furthermore, the problem is not to only develop the resistance or tolerance. We would be very happy if the plants are tolerant, because generally these characteristics are also combined with loss in the quality, especially in the taste. So, and this is the big problem, because you will get the tolerant plant, but no one will buy it because it is not so acceptable from the consumption. A big gap, and we cannot fully fill it on the very proper and quick way. So I think to act directly and in the short term is just changing the practice of the cultivation, and also shift the cultivation, and parallel to this to develop the tolerant, or if we are lucky, resistant new varieties. Thank you.
Okay, the question is not related to my expertise. I'm not a plant scientist, so sorry, I cannot comment on this one. Thank you.
That's okay. Thank you, Professor Malau, for very interesting questions. So let us proceed to, we still have 3 questions from the audience, from the participant. I just read it briefly. The first one is from Dirisa Mugampoza, addressed to Professor Bhesh. Thank you very much, Prof, for your very good presentation. Are there any safety concern for using the ethylene powder in fruit ripening?
There is no safety concern because still the concentration is very low, because it has got 3.5% gas, which is very low. I mean, and at the same time, you are using a very small amount of powder, which doesn't pose any problem, because the amount of the powder you need is in very low amount, because you need in ppm concentration in the air, ethylene concentration. So you use very low concentration. So there is no safety concern. But if in case you have got a powder in bulk, you know, in a big container or something, of course there will be, if there is by chance there is a gas release or something, there might be some issue, but that's unlikely to happen that way, because you will be packing the gas into the very safe condition. It's not like a compressed gas in a cylinder, which is very unsafe.
Okay, I think this is a related question as well. This is from Professor Anna Keutgen, addressed to Professor Bhesh Bhandari. So, is there any risk of the use of ethylene powder, especially at the beginning of the fumigations? For example, explosion or because of such high concentration in the powder. So, I think it's partly has been answer previously, or maybe Professor Bhesh will have another comment. Please.
Yeah, there is no safety concern, because fumigation doesn't mean that you're having a fire, you know, it's just like you fumigate with the smoke. And then, as I told you, that you are using very small amount of powder to get that ppm concentration. There is no risk of any explosion or anything when you are using the powder in a ripening room. During fumigation, yes, you can do that, or before the fumigation.
Okay. Can we somehow influence the concentration which we have to achieve?
Sorry?
Can we somehow may influence the concentration which
when you are
would be
fumigating?
released?
Yes, when you are fumigating, you have to consider the concentration, because when you do the ethylene application, it has to be completely sealed room. But fumigation, probably, of course, it has to be sealed room. It may change the concentration, and you have to think about the interaction of fumigating compound with ethylene as well. So how it is absorbing, how it is affecting, that has to be done as a separate study. So I cannot comment on that one. Yeah.
Okay. We still have one more questions from Dr. Hartati Oktarina, addressed to Professor Anna Keutgen. There are tons of research on environmentally friendly plant disease management. But until today, the use of synthetic chemicals still the most effective and the most favorable. Take Indonesia as an example. What are your thoughts on this?
The aim and the development here in Europe is to reduce the use of synthetic chemicals. And even so, that we have no alternative. This is a big problem, because there is the very big pressure also from the society that there are toxins, not only to the pests, but also to the humans and the environment. And in the last years, many pesticides are just forbidden, and we have a problem how to deal with. And the way is to take to change the crop rotation, to use the natural substances. They can be also very effective toxins. And what is also important when we speak about the commercial use, we have to get the legal permission to use them. So this is not so easy to answer, because one new development is maybe applicable to the cabbages, but it is not allowed to use for the spinach, even when the same insect is just damaging the plant. So this is the thing, and this is a big issue to use as less as possible, as much as it is just active and reducing the disease or pest to the level, not completely to remove them, but reduce to the level that the economically losses are tolerable. This is the new development, what we have to deal with. So it means in the consequence that also here the quality will be not so ideally.
Okay, thank you very much for the question and answer, and also the very nice discussion. Due to the time constraints, I'm so sorry that we have to end this session. So thank you so much for Professor Bhandari and Professor Keutgen for sharing your knowledge and experience with all of us here in Indonesia and all around the world. So let me read just brief summary from both presentation. So the ethylene is a flammable gas which is needed for fruit ripening. So therefore the conversion of this gas into powder is really a good achievement in food technology research. So possible application for this product is for replacement of compressed ethylene cylinder, as well as for powder for ripening large and small volume of fruit, and also for in-transit ripening. So it is also possible. So from Professor Keutgen presentation, we can say that beside the negative effects of the climate change, so there are some positive effects as well. So the negative effects for the climate change are the increasing temperature, so more frequent heat waves, water shortage and drought, even will be more serious constraint on growth and the quality of many crop plants. And however, the positive effects, so there are some as well. So higher average temperature will accelerate the development of many plants, and increasing CO2 concentration in the atmosphere to a certain extent actually may stimulate the plant growth. So that's all for me as the moderator. So I thanks one more time for the keynote speakers for very interesting presentation and your time spending with all of us here in this afternoon in Indonesia time. So I apologize if I made mistake during moderate this second session. So I close. Assalamualaikum warahmatullahi wabarakatuh.
Thank you. It's my pleasure. Thank you very much.
Thank you very much.
Thank you very much for Professor Dr. Ing Sri Haryani S.T.P. M.Sc for a very fruitful moderator session. Ladies and gentlemen, now we will witness again the symbolic delivery of certificates by the Dean of Agriculture Faculty of Universitas Kuala to our keynote speakers, Professor Bhesh Bhandari from the University of Queensland, Australia, and by the head of Research and Community Service Institution to Professor Anna J. Keutgen from University of Natural Resources and Life Sciences, Vienna, Austria.
Prof. Anna J. Keutgen, thank you very much for your contribution as a keynote speaker in our international conference on agriculture and bioindustry 2022. We are very grateful for your excellent presentation and fruitful discussion. Please accept this token of appreciation from us. Thank you very much.
Dear Honorable Professor Bhesh Bhandari, on behalf of the Faculty of Agriculture, Universitas Kuala, we would like to thank you very much for your great contribution as a keynote speaker for the 4th International Agriculture and Bioindustry Conference 2022. Please accept this certificate as your contribution as a keynote speaker. Thank you very much and hope to see you again. Thank you.
Before we jump to the next session, we will select 8 lucky participants to get 3 pieces of beautiful t-shirts from Agriculture, Mechanization and Workshop Research Center and 3 packages from Biocar and Forest Conservation Research Center, as well as 2 more packages from Coffee and Cocoa Research Center, Universitas Syiah Kuala. To the operator, please let us see the names of the 8 winners.
Yes, this time the door prizes seems very interesting.
Yeah,
I personally really like coffee and cocoa.
Yeah, they always are.
So okay, we got the first winner that get 1 piece of beautiful T-shirt from Agricultural Mechanization and Workshop Research Center. Now, operator, we will select 2 more participants to get 2 beautiful pieces of T-shirts.
Yes.
Okay.
And who will it be this time?
Let us see who will be the winner of this time.
And it is...
Okay.
Congratulations to Miss Junita Marisa Putri.
Yes.
Yeah, you will receive a beautiful T-shirt from Agricultural Mechanization and Workshop Research Center. Let's see the final winner of the beautiful T-shirt.
Another name that will get a T-shirt.
Yeah, the last one. Let's see.
Who will be the winner this time? Okay, another female. We got
congratulations.
Ovia Angelita. Congratulations.
Congratulations.
Now we will move to the next door prize, which are 3 packages from Biocar and Forest Conservation. So the operator, please. We need to see who will be the winner of this
and
time.
The first winner of this package is...
Okay. Oh.
Here we are.
We got the name.
Primasari Rambi.
Yes.
Congratulations. Yeah.
Congratulations,
You have the right
Rizka.
to receive your prize.
Exactly.
Now, next person. Let's see.
Okay, the next person that will get a package from Biocar and Forest Conservation Research Center. Oh, congratulations to Devia Landana Fitria. You got 1 beautiful package from Biocar and Forest Conservation.
Yeah,
now,
I wonder
Syam,
what the
yes,
packages
you
contain.
can announce who will be the last winner that will get the
last
package.
winner,
Yes.
yeah, for the packages. Let's see.
Let's see who will get the package.
And this time it will be...
Wow.
There you have it. It's Dr. Engineer Sabdi M.Si. Congratulations, Dr. Sabdi.
Yay. Congratulations.
Now, let's select 2 winners to receive a package, each from Coffee and Cocoa Research Center of Universitas Kuala.
Exactly.
Let's see. And the winner is...
The winner is Novia Khairunisa.
Novia Khairunisa.
Yes, congratulations.
Madam.
Okay, the last but not least, we also have one more door prize session, but this time is the last winner that will get a package from Coffee and Cocoa Research Center, Universitas Syiah Kuala. Oh, congratulations to Miss Sania Zulka. Congratulations. Yeah, it's a bit sad because we're not in the wheel.
Aren't we?
Okay.
Yeah. We're not sure because the names are a little small in letters, yeah? So I say my congratulations to the 8 winners of our session for, giving out free merchandise, free prizes for you. Unfortunately, our names are not in it, probably. Yeah.
Yes. Don't forget that all of the winner, please do contact our committee after the end of this session, but also don't forget we will have one more door prize session in the evening. So please stay tuned on Icagri 2022.
Distinguished guests, ladies and gentlemen, we are now going to the second parallel session. For this session, the operator has provided a link that can be accessed into 14 rooms for different speakers and moderators. Therefore, please follow the given instructions.
25 alternated panelists. The result of organoleptic test on the aroma of beef nugget with various percentages of tempe flavor can be seen in table. The result of the analysis of the variety of aroma of beef nugget with a percentage of tempe flavor had no effect. On the aroma, the panelists received somewhat favor with the average of 1.60 to 1.92 or with a percentage of 80.20% to 21.81%. So in the treatment of 20% of the panelists preferred tempe flavor to the higher aroma compared to the 0%, 10%, 30%, and 40% treatment. This goes so the higher the tempe flavor, the stronger the aroma cost, because tempe flavor still has a different aroma, namely mushroom-like flavor, which results in reduced detective aroma of beef. Soybeans contain the enzyme lipase with hydrolyzer or the compressed soybean fat to product compares that cause penny flour. The result of organoleptic test on the texture of beef nugget with various percentages of tempe flavor can be seen in the table. Again, the result of the variety of beef nugget with
station is East Ham.
2:30, and then boiler chicken 6:25. It's mean lower than boiler, although the protein has lower and fat content is higher from boiler chicken. And next, materials and methods. Material we use the OC 60 pitches of its crossbreed, and then BR1 and BR2 feed from the Java complete Indonesia, and then vaccine. Vaccine we use chopper layer from the Medion, and then location of rare is Sleman, Yogyakarta. For the methods, we slaughter use halal method. Halal method is cut 3 channels. This is respiration, digestion, and cardiovascular. And then chemical quality, moisture, protein, fat, carbohydrate, and S content. Physical quality consists of pH, tenderness, water holding capacity, cooking loss, microstructure, microbiology. And then sensory quality consists of color, smell, texture, tenderness, and
According to Fontas et al. To 2015, explained that there are 4 types of smart farming technology currently distinguishable. Number 1, autonomous machine. Machines that are operated independently. Example, weeding and harvesting robot. Furthermore, 2, recording or mapping. Recording and mapping technology that collects location-specific data. Number 3, tractor GPS or connected tools. Tractor and connected tools that use real-time kinetics to precisely apply varying input level and guide the tractor accurately. And number 4, farm management information system or apps. Application and farm management and information system that are integrated and connected to mobile device for easier agricultural monitoring and management. Next. The implementation of SFT is also expected to maintain food security. To achieve community welfare, food security is a major issue in agricultural development. Humans have overcome the increasing demand for food by applying new technology in agricultural activities. Thus, new technology need to be adopted for the sustainability of agriculture in the future. The utilization of SFT can provide benefit for farmer, where farmer can reduce labor, save input costs, and save time in agricultural activities. Next. Material and method. This research has been carried out in 2 districts of Aceh province, namely Bhandari and North Aceh. The research
life cultural and prospective values, and determine the strategy for developing Gayo horse in the area of Southeast Aceh Regency. Next, please. Okay, the number of Gayo horse used as research subject were 55 horses and 30 respondents, 25 horse breeders, and 5 experts. The study was conducted using a survey method with descriptive analysis. The survey parameter used in the study can be seen in the table on the next slide. Next, please. Okay, we can look at all the primary and secondary parameters in this table. I will explain. All the Gayo horse breeders are male, 100% male. Why? Because male domination is closely related to social influence, where men act as head of families who are responsible for earning a living and working. The non-formal education of Gayo horse breeders in Southeast Aceh Regency is very high, while non-formal education is an effort to improve the quality of breeders, to improve attitudes, knowledge, and accelerate to adoption and innovation of technology in the field of animal husbandry. The result of the study, as many as 92% of breeders keep Gayo horse as a mean of cultural ceremonies because of their very high economic value. The prospect of Gayo horses in Southeast Aceh Regency is very high due to the frequent activity and the number of horses that are rented out as mounts during traditional events, with an average of 50 to 40 ceremonial activities in 1 month or 11 months per year, with a rental fee of 150,000 per horse, where people usually rent a horse with an amount of more than 2 horses per event. Next, please. The result of the study show that the value of Gayo horses for breeders is first, economic value, namely as an economic source or income, and also as an investment for the community, as well as a symbol of social and cultural status. And then for the traditional values,
Have you heard this story about a beautiful place? A place that makes you feel restful. In the midst of people who live in religious harmony. A place that makes you feel home, that makes you curious for more adventure. Start your journey. Travel to the place where the story unfolds. Feel the sea breeze caress your face and the sound of the waves breaking your consciousness. That you can see them through the beauty of woven fabrics. Or smell them through the scent of coffee that wafts in the air. If you've never heard it before, you may now find it intriguing. You may want to know every square inch of this place. From the beauty of its land to the depths of its seas. With an amazing biodiversity. Perhaps you've heard this story about a land which has traditions so diverse. Meet these friendly people who will welcome you with warmth. After all, welcoming guests is their tradition. The light of Aceh, wonderful Indonesia.
Have you ever wondered about the beautiful land above the cloud? The beautiful place known as the land with a thousand hills. This is the wonderful paradise with a great experience. The melody, the diversity created one of the unforgettable stories. Can you imagine? They serve you a great meal persists in front of your eyes. This place also has the special part about the history of Indonesia. Knit perfectly the relation between coffee and woman. The sensitivity of choosing a good bean. They are the creator of that perfect taste. Enjoy your time with one of the big mammals.
Have you heard this story about a beautiful place? A place that makes you feel restful. In the midst of people who live in religious harmony. A place that makes you feel home, that makes you curious for more adventure. Start your journey. Travel to the place where the story unfolds. Feel the sea breeze caress your face and the sound of the waves breaking your consciousness. That you can see them through the beauty of woven fabrics. Or smell them through the scent of coffee that wafts in the air. If you have never heard it before, you may now find it intriguing. You may want to know every square inch of this place. From the beauty of its land to the depths of its seas. With an amazing biodiversity. Perhaps you've heard this story about a land which has traditions so diverse. Meet these friendly people who will welcome you with warmth. After all, welcoming guests is their tradition. The light of Aceh, wonderful Indonesia.
Ladies and gentlemen, welcome back to Icagri 2022. Finally, after a tiring parallel and discussion session, we have come to a very nice door prizes session.
Is it already?
Right now?
Yeah.
Okay, could you tell me what kind of door prizes that we'll get this time?
We actually have 6 more prizes to give.
Wow.
The first 3 are going to be packages from Biocar and Forest Conservation Research Center.
Okay, again from Biocar,
yeah.
yes.
So they've provided so far 6 prizes, yeah? And the other 3 prizes for this section is going to be 3 t-shirts from the Center for Sustainable Agricultural and Rural Development of Universitas Syiah Kuala.
Okay, again.
Look.
Yeah.
The wheels are
already spinning. Okay.
Yeah.
Okay. Let's
And
look at this time. Who will be the winner?
name is-
Wow! Congratulations to
Miss Gina
Erida. Congratulations.
Miss Gina, you will be receiving a package
yes.
from Biocar and Forest Conservation Research Center.
Yep.
And already spinning on.
Okay.
Let's see.
Let's see this time who will be the winner that will receive a package from Biocar. Oh, congratulations to
Yes.
Dr. Insinyur Fikrinda M.Si. Okay, the last person that
win
will
the
get
package, yeah?
Yep, the package from
the wheel is
Biocar.
spinning already, and
Yes.
it's going to be.
I think it's going to be one of us. Am I
Please
right?
be one of us.
Please. 2.
Fortunately, it's not one of us.
Yes,
It's-
but congratulations
yeah,
to
congratulations,
Hikmah
anyway.
SPMSI. Okay, move on. Now we will select 3 participants that will receive T-shirts from Center for Sustainable Agriculture and Rural Development, Universitas Syiah Kuala.
Yeah, that's right. We will now see the first name to receive the
Okay.
T-shirt.
The first name that will be getting a T-shirt. Oh my God!
Yeah, congratulations to
she-
Wilda Hikmah.
Yeah, she actually my friend.
Really?
Yes.
Yeah.
Yeah. My
You may-
a high school friend. Yeah.
Okay. All right.
What a lucky name.
Yeah.
Okay. Okay.
Next up, we
Next
have.
up.
And.
Okay. I'm so curious about who.
And so am I.
Okay.
It is
Sodik
Diki
Diki
Darmawan.
Darmawan. Congratulations.
sir. Yeah,
Yay.
you have the right to receive a T-shirt from the
Yes.
Center for Sustainable Agriculture
Exactly.
and Rural Development.
Now we
of
will
Universitas
select
Syiah
the
Kuala.
last lucky participants that will
Really?
get T-shirt.
Can't we just give it to one of us
No,
without spinning the wheel?
It would be unfair.
Okay.
Okay, it would be unfair.
All right.
Okay.
Let's see the wheel.
Okay.
The wheel shows.
Zalniati
Okay.
Fona Rosali.
Yes,
Congratulations to
Congratulations,
all of the
yeah.
winners.
Congratulations.
Once again, congratulations. I'm a bit sad actually because I put myself in the wheel, but I
Well,
didn't get chosen.
I understand you.
Okay.
I put my names twice.
Okay. Anyway, the selected winners, please do contact us after the end of Icagri 2022. Thank you.
Ladies and gentlemen, we are now nearing the end of our conference. And with that said, we are now going to listen upon the closing remarks and the announcement of the best presenter by the Dean of the Faculty of Agriculture of Universitas Syiah Kuala. Ladies and gentlemen, please welcome Professor Dr. Insinyur Samadi, M.Sc.
Okay, thank you for Syam and Diva to give me the opportunity to announce the best presenter in the 4th International Conference on Agriculture and Bioindustry.
The best presenter?
Okay, we have 14 rooms for the parallel sessions. The first winner, I think, is the best presenter for the room 1 is Djufry with the paper ID 87. Congratulations for Djufry. Okay, give applause. The best presenter in the room 2, Miss Yunita with the paper ID 77. Congratulations. And the best presenter in the room 3 with the paper ID 73 goes to Darul Rahmi. Congratulations to Darul Rahmi. The best presenter in the room 4 goes to Rosmalia with the paper ID 41. The best presenter in the room 5 with the paper ID 9 goes to Professor Saban. Congratulations to Professor Saban. The best presenter in the room 6 is A.M. Muslih with the paper ID 100. The best presenter in the room 7 is T.P. Ahmadi with the paper ID 103. The best presenter in the room 8 goes to Fadjry with a very high score here is 95 with the paper number is 160. The best presenter in the room 9 is Tran Tien Hien. I think this is from Vietnam, right? Is with the paper number is 164. The best presenter in the room 10 goes to A. Nugroho with the paper ID 151. And the best presenter in the room 11 goes to Nur Mayazah with the paper ID is 200. The best presenter in the room 12 goes to Emi Nur Astuti with the paper ID 107. The best presenter in the room 13 goes to Icagri is with the best with the paper ID is 134. And last, the best presenter in the room 14 goes to Novi Andri Setianto. I think he's my friend, is from Unsud Purwokerto. Congratulations, Pak Andri, with the room now with the paper ID 124. Congratulations for the all presenter. They have give a very good contribution for our conference today. Thank you. Okay, Assalamualaikum warahmatullahi wabarakatuh. Now we are at the end of this international conference on agriculture and bioindustry. I think all the participants and also the committee is very tired, just sitting in front of the computer from this morning up to now. I think everybody also very happy, can get many knowledge that come not only from keynote speaker but also during discussion session. In this very good moment, we would like to thank you very much for the Rector of Universitas Syiah Kuala to facilitate for this conference, and also for the all keynote speakers that contribute to our conference today. Of course, thank you very much to the chairwoman for this international conference, for Dr. Elvira Iskandar. We can give applause to the chairwoman for this conference, and also all the committee members that already prepared for this conference, not only for today. I think it's months ago to make this conference is very successful. Also, all the participants that we got information for the committee is more than 300 participants join with this conference with 135 papers or article come from 35 countries in the world. This is a really, really international conference. And congratulations also for all the committee. They already organized this conference. So we still have one more task to finish this conference. We have to publish all the articles that are already presented by the participants. We have 135 papers. We hope all the papers can be published in the IOP Scopus Index. That we hope. And also, on behalf of the Faculty of Agriculture, Universitas Syiah Kuala, we would like also apologize if you find something not convenient during this conference. By saying Alhamdulillah, the 4th International Conference on Agriculture and Bioindustry officially closes. Thank you very much, and see you in the next Icagri 5 2023. Assalamualaikum warahmatullahi wabarakatuh.
Thank you very much to our Dean, and once again congratulations to the selected best presenter. And that wraps up our session for today. Ladies and gentlemen, on behalf of the Committee of Icagri 2022, we would like to say thank you for making time in your busy schedules to join us here today. I am Diva Sabina and my partner
Muhammad Syam Aligustion.
See you on the next conference. Wassalamualaikum warahmatullahi wabarakatuh.
Oh, di sini.